originally at the campus, and then we have one at the Oslo EX, or Bulk, also known as HMG9 or HMG9. And then we have stack infrastructure, which is formerly known as Digiplex data center. So it's 1 gig, 10 gig, 25 gigs, 100 gigs. We still have some on 1 gig. We hope to get them over to 10 gig soon. The price is the same, but they still are on 1 gig, so for some reason. Then we have NIX2, which is a secondary IXP. It's completely isolated from NIX1. And it's placed in Christian August gate 17, which is a location, a building owned by the university. It was moved a couple of years ago, but there's also the 1, 10, 25, and 100. So then we have 4 smaller ones distributed in Norway. So it's the 6 Stavanger in Stavanger, in Green Mountain, 1 and 10 gigs, and then we have BIX in Bergen, which is only 1 gig, not many customers there, and in Trondheim, and then we have one in Tromsø. The one in Trondheim also has DNS road servers. I think it's PGH. And on NIX we also have NIX1 and NIX2. We also have DNS names road servers. Root servers. Yeah, I think that's good. All of the IPs are using IP segment dedicated by RIPE, except for BIX. It's kind of should have been done a long time ago. We have very few customers, so very little traffic, so it's kind of been put down on the list, not prioritized. We have a bird route service, which has been in a long-lasting pilot, but it's kind of it's in production now, or ready for production at least. Yes, we have been cooperating with NetNode not since 2019, but in 2014. Both technically working together with them, and they are also selling NIX as kind of a Scandinavian solution for more international customers. So it's kind of, yeah. We have 1 new member in this year. No resignations. We have 5 members on 100 gig. Around 40 members on 1 gig still, which we should have got over to 10 gig. It's the same price, so the one of you have 1 gig, you should go to 10 gig. That's a tip. 50 members with selecting a pairing policy on the road server, and selecting 22 members using the road servers. So we want more of you over to the road server, but we have not been marketing that much. We're not very good at marketing, so this is the best I've done so far. We are a university. So this is NIX. This is from the IXP manager, which is kind of the center of the universe for us. We have 68 members or customers in total. 67, not 68, 67. One of them is a test user for us, so 67 at the point of time. And 13 are also on the NIX2. 6 is the one that's kind of growing. Traffic is increasing. And also more member has joined lately. Probably mostly, it's in Green Mountain, it's a good location, but probably mostly because Microsoft is also connected there, I assume. The other ones, BIX, Trondix, and TIX are very stable, very few as you see. But we are operating them together with the other universities. BIX is with the University of Bergen, Trondix is with NTNU, and TIX is with the University of Tromsø. So it's kind of low cost, really. The traffic, around 160 gig, not much. We are small, maybe small to medium IXP. But the total traffic 160, and NIX1, which is the biggest one, is 140, around 140. Yeah. NIX2 has the traffic and the members, or the customers connecting to NIX2 has been declining. So the NIX1, the main one, is just very easy. We do stuff pretty easy. Hopefully it's stable and pretty cheap, at least reasonably priced. But we do it easy. So it's 3 locations. It's redundant. It's the University of Oslo. It's the OSIX, and then it's the former Digiplex location. So pretty easy. It has been stable though, so it's good. NIX2, just before the pandemic, in the last meeting, we were on our process of moving NIX2 to Kristian Augusts gate, another location. This was the former building. This triangle here was an old building, and this was a very new building. And we moved over the street. It was quite a project, really. A lot of fibers had to be moved, not only for the IX, but also for it's a central place for much of our equipment, and also for the Uninet or SICT and Nordunet, the NRAN research network. So there was a lot of fibers that had to be moved, and it was quite a big project, but it went well. So now we are placed in the Kristian Augusts gate 17. And of course, NIX2, I think that's a question absolutely for a dinner later. Do we need it? Should we do something with it? And yeah, what's the future of NIX2? At 6 in Stavanger, the traffic has increased a lot, and especially probably because of Microsoft moving there, but that's one of the few that's really have increased. Most of the other ones are pretty stable, both in traffic and members. So during the COVID, the pandemic, we saw, of course, or not surprisingly, increase in traffic. This is you see from February to March there, and you see almost a doubling of traffic. And you can also see here that it changes. So this is the lockdown in Norway, Thursday the 12th of March 2020. And it's not a big change, but you can see there's a change in traffic here from people working from home or than from the office. So there was quite noticeably, and you can see it even more on Monday there, where you see traffic changes there. So interesting. You also see, of course, naturally, that the traffic is changing also in what's inbound and outbound on NIX. So typically, when you move at home, this is from an ISP. So you'll see the traffic changes by people working from home. Yes. During this period, we worked a lot. We did the best we could for you and for the university and for everything else that had to be done. There was a big change in the university too. Professor changing from doing things physically to digital at the university is not an easy operation, I can tell you. But also at the NIX was important to be really hands-on and upgrade links, and also the capacity in general. So we daily and weekly had dialogue and reports with departments, or the government, I mean. And the focus on NIX got a lot greater than we were used to. And I think that's good for Norway, that the government are kind of understanding that there are some infrastructure that's kind of important for internet in Norway. So we also have had a lot of dialogue with you guys and girls, or men and females. It's more politically correct, I guess. And we did our best, and I think it went quite well. And there's probably a lot of learning from this period and what to do. Another question for the dinner, I guess, which is I'm looking forward to, at least. So we got some money from I'm not sure how to describe it, but ANCOM, it's not a government agency, but kind of it's a government department that's gave us 750 Norwegian crowns, 1,000 Norwegian crowns, to increase the robustness of NICs. As I said, the focus on NICs from the government has increased a lot. Now, at least they know what it is, kind of. So we got some money, increased the capacity, and also capacity and robustness of the DNS road servers. Root servers, and also the robustness of NetFart, which is a kind of a measuring service for customers using internet. We also have had some dialogue with Justervesenet. Those are the one who are responsible for time and frequency in Norway. Netnode has done a lot of that in Sweden. Norway is quite far behind, really. But we have had a quite a tight dialogue with Justervesenet, and we're planning a pilot where to put as a cesium watch, the clock, and using the White Rabbit at the university together with NICs in the same location. Mostly to use the same hands-on, to see the same locations and some of the advantages we have at the university and NICs. Unfortunately, we're planning a meeting this fall, but it got postponed. So I'm not sure what happened, but for some reason the Justervesenet didn't have time to make it happen. So.
They didn't have time.
Of course. Or the wrong time, I don't know. At least I'm hoping for more dialogue there, and I really hope that we could do something, especially together with Netnode, who has a lot of competence, experience in this field. And maybe we could have one watch in Norway and synchronize with some in Sweden, and can start working on that. If there are people out there who see the need for this or really want to work with this, please contact us, and maybe we could do something together. This is kind of putting people in the right people in the right room, or in one room, and just trying to find out how should we do this in Norway. And I think it's quite important, really. So IXP Manager is the kind of the center of the universe for us. IXP Manager was made by INEX, quite big Irish IX, and EuroIX and many more has started to support that project, and it is, I think, been used by around 80 to 90 different internet IXs in the world. It's tightly connected with the road server, so we are getting the configuration, or the IXP Manager are making the configuration for the road server. And it's getting information from different databases like IXPD, PDB, and other databases where you put in your information, and it collects it from IXP Manager collects it, and it makes config from that. So it's very important that you update your information in the databases that you define. So it's very easy, really. We're using something that many others use, and we're trying to follow the standard of the IX community. So as I said, IXP Manager, sponsored by many, also us. Unix is also sponsoring this, and we're also sponsoring, have been sponsoring an BGPD, and the Fruit name root server. Road servers, as I said, it's the IXP Manager generates the configuration. It's two bird servers. Pretty easy, really. You will define in your profile on IXP Manager what you need, and we have to do a little bit around the AS numbers, AS set, and stuff like that. But normally, everything is done automatically. You will find your MD5 secrets also at your page on the port page. So, if you're not on the road server and want to go on the road server, contact us and we will help you get connected. But it should be pretty easy. The pricing at Nix is status quo. It's we are still reasonably priced from average and down. As you see, the 1 gig has the same price as the 10 gig, so there is no reason for using a 1 gig. If we probably should do some marketing there or some information, sending out some information, but if you have using 1 gig and sitting in this room, you should change to 10 gig. And also 25 gig is the new one, 10 gig, but all of this you probably know. So, at the regional IXs, there are no connection fee, but then and the price is a little bit less. Yeah. We are doing invoicing this in the October, and the things that's important is that we get updated the billing details. So if you haven't done that, please do so. That will help us a lot. So. And probably make it easier for you too. Point of contact. One of the maybe advantage that we have at the university is that we are a quite big IT organization. So we have a 24/7. We have a lot of people that are able to help if necessary. So and it's very cost efficient. So we have. It's possible to reach us 24/7, but preferably in working hours, and also if you contact us for critical measures after working hours, there might be a cost. So we are not very good at sending bills, but we are doing our best. So. Have some mailing list, different mailing lists for different IXPs, and one for them all. That's kind of it. We really want to hear from you what you think about what we're doing and if it's good enough. I think we are stable, but not the most modern and fancy IX. I think we're reasonably priced, but we really want to hear from you what you think, and if there's something you want us to do or change or impacts your normal day. And we have a dinner for that. So then it's Kjetil Otto Olsen is going to tell a little bit about
Well, I'm not going to say that much, but as most of you probably are well aware of, we are cooperating with Netnod, done for many, many years. And in April this year, LM, the CEO of Netnod, and myself, we announced that we were going to cooperate even closer. So we are working on a much closer relationship with Netnod to create a kind of Nordic IXP solution that you as a customer can then go to and have a Nordic IXP product. This is of course not very easy because Nix is owned by the Department of Higher Education here in Norway. They don't really understand what an IX is, even though they understood a little bit during the pandemic. So we're working with them to get them on board, and we have a good talk with Netnod. And we hope that we had hoped for having something ready this year, but it might take a little bit longer because when you involve government and politics, it takes time. So, but we're working on it, and I think we're having good progress, even though we have nothing really to show for today. But we are working on it, so we'll get back to you as soon as we have more details. If you have any questions about it, ask either some of the Netnod crew here, or me, or Petter, and we will try to explain as good as we can. But as I said, it's a work in progress. So thank you.
So that is Emil from Netnode.
See if this works. That's not the one. That's our presentation.
No, it's not open.
Ah.
That's why. Should be one of these. The one with
Yeah,
the
that one.
They double click it. Maybe this one?
Yep. Perfect. So I am Emil from Netnode. I've been with Netnode for 3.5 years now. And I'm here to talk a little bit about what Netnode is doing. I think most of you actually know what we're doing. We are one of the big four, as they're called, of the IXPs in Europe. So Netnode is based in Nordics. We have Stockholm, Gothenburg, Copenhagen. We recently opened in Helsinki. We have Sundsvall, Gävle, Luleå, and we also have Oslo in a partnership with Nix. So we basically, if you have a customer in Stockholm, you can reach Nix with an additional fee, and vice versa. So if you're connected in Oslo and you want to reach Stockholm, you can do that through Nix. In March this year, baddest time ever to launch an IXP in Helsinki, but we did. It's been on our books for at least 2 years. So we are present in 3 POPs, Helsinki, Digita, which is the largest one, which also houses the Fikix, Equinix HE7, and Telia data center in Helsinki. Helsinki has a special offer at the moment. There is no cost of connecting there. So if you are in Helsinki area with equipment, just let us know and we'll set you up. There's also a possibility to get remote IX from Helsinki to Stockholm for free until July 1st, 2023 actually. We were going to start billing it, but it's quite hard to get Russian customers right now. So there's not that much traction in Finland. We also do a lot of transport. We don't only sell IX services. We do VDM transport. We do remote IX, as we said, and also layer 2 transport within the whole of Scandinavia. That's nothing more to say about it. We don't have VDM transport to Helsinki, but the rest of them we have wavelengths accessible. We do shaved ports in increments of 10 gigs. We can actually do 400 gig ports also and do 100 gig steps if you want to do that, but no one has ever jumped on that train yet. But mostly people are actually using 100 Gs because it lowers your cost for cross connects, and you do additional 10 G port additions to your 100 gig port instead. So basically it's a shaping. So we talked a little bit about remote IX. So here's the pricing. So if you're from Oslo and want to reach Stockholm or Helsingfors or Copenhagen, it's 5,000 Swedish crowns per month. It's not that hard to set up. It's basically just a software configuration for us, so it's not that long lead times. We also run, so Netnode has 3 legs, if you didn't know. We have the IX part and transport, we have the DNS service, and then we will get up into what Petter was talking about, which is time and frequency and stuff. But DNS, we run any cost networks of DNS service around the world, so we are in 80 locations globally, serving large TLDs and also enterprise customers. We have also been one of the iRoute services, iRoute, since 30 years. It started with one of my colleagues who actually started when he was working at KTH, so which has also the same as UU. And time and frequency. This is one of the things that we are actually exploring quite a lot around right now. Since we have the increase of 5G and power plants needed specific time, we have banking laws that says you have traceable time and so on and so forth. And we have been tasked by the Swedish PTS, which is the regulatory body for internet traffic, time, banking, not bankings, but they are tasked us with doing time in Sweden. And that's been going on for a long time. We've previously just been doing it on PTP and NTP, but now we are also doing, what is it called, Matte? I lost my words. Yes. What is it called? PTP. Yeah, it's PTP. Not the NTP. Yeah, that was the previous one. Now we're doing PTP too. So we have cesium clocks in 5 different locations in Stockholm, in Sweden, 2 in Stockholm. But all of them are set up with redundant atomic clocks. So we have 2 setups of everything. So we have 2 switches, 2 atomic clocks, something that correlates the time between them. And it's actually measuring the frequency that a cesium atom, something, jumbo, I don't know. We have people who works with this. It's not me. Trust me, I'm a network engineer. The latest offering that we actually announced last week is something that we call NetNode Time, local and robust accurate time. It's divided into 2 parts, where you have NetNode Time Remote, which actually provides you with a CPE. Or no, is that the CPE? Yeah, I'm very new on this one also. Time Remote is PTP. Yeah. So Time Remote is PTP, where we actually distribute PTP from our cesium clocks out to the edge node, so we can provide that over the IX. So since we're running Arista, we have a native PTP support in them. So we can guarantee low latency and a good accuracy on it. We also have the NetNode Time Direct offering that is coming out, which is actually a CPE which will place in your where you want it, where we will synchronize that with our clocks in Sweden, and then hand over a frequency to you. We also provide a PTP service centrally from these locations. So if you're in Stockholm, Copenhagen, Malmö region, Gothenburg, and so on, you can get a PTP signal from us. And back to stuff that I know. So NetNode has been one of the founders of the Route Server Support Foundation, which is basically helping to develop and have OpenBGPD be up to par route server. We've been running Bird for many, many years. It's been working good, but we've came to the conclusion like 2-3 years ago that we actually need to have some vendor diversity when it comes to route servers. We can't just rely on Nick Zizad to do Bird. We have to have someone else to not have the same software issues on both our VLANs at the same time. And then Job Schneider came up and said, how about OpenBGPD? And we said, OpenBGPD cannot do route service at the moment. And then he started the Route Server Support Foundation. And it's been going on we've been supporting it for 1 year. And we are actually currently running OpenBGPD as a route server in Helsinki, which was the first place we put it live in June this year, right before the EuroX meeting. We also have the European Peering Forum. I don't know if anyone here was there, but it was last week in Rome. Yeah, Kjetil was there. Kjetil is always there. But this year it was hosted by Lynx in Rome. Next year it is hosted by NetNode, and it's going to be in Prague. So hope to see all you there. And if you have any topics for presentations or interesting sponsors, please get in touch with Siri, who is the lead on that. NetNode has always been like the biggest, one of the bigger IXP who doesn't have a customer portal. We decided to change that 2 years ago, but we started to realize like how do you actually centralize all your data around building a customer platform, customer portal, and it's really hard, especially when you have like Perl scripts that generates your configuration files for your route servers, which are actually not config files, but Perl scripts, where you define all the ASets. So we had to do a lot of things behind the scenes and migrate all that data into some place where we can have it accessible. And we actually came to fruition this, I think it was announced at the NetNode meeting, and that was April, where we actually went beta testing with some customers. Now it's more open, so everyone can sign up. And for the moment, you can see stats per port, bit errors, light levels of your port that you have. You can see your invoices, your contracts, and technical details such as route server information, what ASet are you supposed to be using on the route server, and so on and so forth. What we are looking into doing next is doing upgrades. So you can basically just sit in your portal if you have a shape port and go, oh, I want 20 more gigs of traffic. It will just automatically provision. Same thing, ordering new services. So this is, yeah, that's my name. So this is the portal as it looks like right now. It's not based on IXP Manager. IXP Manager works really good if you have a small IX where the only product you're trying to manage is an IX. We have DNS, time and frequency, and we don't want to have 3 portals, so we built our own. For example, this is how it looks when you look at your IX service. You can see which MAC addresses are supposed to be provisioned on your ports that we are accepting through our filters. We also provide you with what route server peering sets you should be using, what ASN number you're supposed to be using, and so on. So yes, it is open sign up. So if you have an existing contract with NetNode, you can just scan that QR code, go to the link, sign up, you will get an email, and so on. And lastly, like small thing, recap about NetNode. We are a neutral internet exchange. We are tasked with doing time and frequency. We host iRoute. We do TLD DNS services. And that's pretty much it. And if you have any questions, I think 4 of my colleagues are here for the dinner tonight. Don't look for me. I'm not going to be back in Stockholm. But yeah, have a good day.
Yes, thank you, Nix and NetNode. Now we basically have time for a coffee break, a bit longer coffee break, as far as I understand, Nix and NetNode have finished a bit earlier than their program. So I think we can go out and have almost a half an hour break. And then we can return to the remaining of the program. Thank you, everybody. Yes. Was it okay with a bit longer break? Yes, I'm glad you enjoyed it. I think we all needed it after so many years without interacting. So we are now ready for the next presentation, and it will be by Ole Pedersen from Hafslund Fiber about dark fiber 2.0. Ole Pedersen is a CEO of Hafslund Fiber, and he has worked with the Norwegian telecom and fiber infrastructure for about 3 decades. And among his most recognized feats are the development and exit of Hafslund's highly disruptive dark fiber venture in the late 2000s, and the scale-up and successful exit of fiber ISP Linet in the middle of 2010s, and the most recent establishing of Hafslund's new dark fiber operation in Oslo. So Ole and his team will talk about 2 strategic pillars for the next generation of the fiber network: quality and the self-developed ERP system. So just to take over, Ole, I think you can take over this one too.
Kan dere høre meg?
Det kun streaming.
All right.
Så jeg tror du
Okay. Thank you, Marius, for your introduction, and hello, everybody. Thank you to Nonog for having us here. It says 3 persons on that slide, 2 of them out sick with flu, probably man flu. But that leaves me with a kind of predicament, because my role was to talk about some high-level stuff about this company and let 2 of the most technical people in the company explain in details what we mean by the dark fiber 2.0. So now I could either do a lot of marketing fluff that would make you really angry, or I could go into pretending I know the technical stuff, and then you would laugh. So I will just basically go down to try to explain what we are, what we're trying to do, and why it matters to you. And I was asked in the break if I could prolong this session, this speak, and I think that could be painful for both of you, me and you. So what I suggested was that I try to interact with you on the tail of this presentation. So I could just give you some kind of challenge. If you, during this presentation, could think a little bit what you would like a dark fiber provider to be. What sucks today by acquiring dark fiber, and how should it be seen from your perspective? So we could maybe have a little bit discussion and views on that. All right. This is telco in the old world. A lot of proud legacy here in this city, actually, when it comes to the internet. I think you guys from the NICS know these details better than me, but it was 74 that Norway was connected to ARPA, was it? 73? I don't know, but Norway was one of the first countries outside the US, or actually the first, I think, outside the US, connecting to the internet. A lot of research done on the early internet stuff from Norwegian academia and internet smart people. All right. But in order to explain what Hafslund is, we need to take a little journey 17 years back. In 2004, there was a small team going into Hafslund, being one of the largest utility companies in Norway with a large electricity distribution grid in Oslo. They came to this company with a suggestion that they should make a dark fiber network with a wholesale business model, meaning no services, no content, no nothing, just dark fiber to make the wholesale customers being ISPs, system integrators, academia or the universities and the NICs, providing them with the physical infrastructure they need to make the best networks possible. Hafslund bought into this idea. This team worked for like 6 years, and after 6 years, this small company with 10 to 15 people working with this had the largest fiber network in Oslo, bigger than the incumbent Telenor. It was a really, really fine network, and the market at that time was very vibrant. A lot of ISPs working both towards the residential market and the business market. A lot of system integrators, actually a lot of companies. And everything worked very fine. And suddenly some people in Hafslund, you need to be some kind of financial voodoo priest to understand this, but they actually sold this network to private equity in 2010. And this network is now the basis for Global Connect's physical presence and footprint in Oslo. All right, so that's the kind of history. So Hafslund made this fantastic dark fiber operator, almost one of a kind. You had a few other dark fiber operators around the globe, but maybe, I don't know, 10 companies, something, 5. They sold it and was finished with all telecom. When Global Connect got this company, or BroNet, which was the name of Global Connect at that point, got this fiber network, they did what all vertical integrated players do. They try to consolidate the market and reduce the outflow of dark fiber, because outflow of dark fiber, cheap and reliable dark fiber, will make all their competitors more successful, and that will hurt their end customer interests. So they will try to reduce it. And that has been the case since Global Connect got this fiber presence in Oslo since 2011, 11. Prices are more or less stable, but it's not so easy to get dark fiber anymore. Their go-to product is kind of lit service, like Ethernet or wavelengths, something like that. So dark fiber is kind of not that easy to get anymore. Depends who you are. And this is bad news for everyone not having their own physical network. So if you're a vertically integrated telco, you are Telia, you are Global Connect, you're Telenor, fine. You roll out your fiber, you make all your services, it's mobile, it's whatever it is. But for everyone else, kind of hard time. So as you can see, there's a market opportunity there. So that brings us to present day. In 2018, the core team from the old Hafslund went back to Hafslund and said, guys, we should do this one more time. But this time we will use the district heating infrastructure. And after a little while, they bought into the idea, and we started again in 2019. And I think we were like 4 people when we started, now we're 10. So in 3 years, we have built approximately 150 kilometers of fiber in Oslo. I mean, that number doesn't tell that much, but it means that we are now covering, why is there not, okay, it's a PDF. All right, we are now covering all of Oslo. This should be some kind of interaction, but we are on a PDF and not a PowerPoint. So on the back side of these small squares, you can see the whole network. We are basically covering all district areas of Oslo, from west to east, and to the forest in the north and the fjord in the south. That means we cover all buildings that should be of interest to anyone who sells services or content or whatever and need to access an end customer. The network has been carefully planned as ring structure, so a lot of rings everywhere. As soon as we see the possibility for closing a ring, we will close it. It's not that easy to see here, but for instance here. So we build a network, we see that, okay, here's like 500 meters, let's just do it. We don't have a customer supporting it, but we will do it just to steadily increase the resilience and robustness of the network. Yeah, I think that's it. Okay, so what sets this fiber network apart from other fiber networks? And I think simplicity is the key word here. First of all, it's pure play, it's dark fiber, nothing else. So there's a saying that if you try to be everything to anyone, you accomplish to be nothing for anyone. And if you are vertically integrated and you want to do everything, you are a mobile carrier, you're a fixed network carrier, it's services, it's content. I mean, a lot of telcos now are going into content, actually producing content, like motion pictures. It's weird. So we're not doing that. It's only the physical infrastructure. And this is a crowd of very highly technical skilled people. There are also like hardcore people on the fiber side, all creeds and colors. And the 10 people working here are extremely dedicated to the fiber, shaking up on how the splice boxes are welded together and how you can modify it and order some weird stuff to make the patches, no, sorry, the splices a little bit more secure, stuff like that. That's what we do every day we go to work. We splice where we can and we patch where we must. So we love to splice. And most old school traditional telco networks, they patch a lot. So we have a lot of patches in the network. And that reduces quality. There's a possibility for errors. And the quality parameters will be reduced because you patch and don't splice. So we're very into the splicing of connections. That means when you order an access, there are sometimes no patches at all. So only splices, all the way from point A to point B. Yeah, there we can also talk about the right-of-ways. The district heating pipes are located on 180 centimeters below ground. So basically like this. An ordinary telco pipe is located like this. And that means also the pipes are, for the 40 millimeter pipes for the fiber cable, are located between huge water pipes. So if some drunk digger has his digging machine and dig into the ground, he will probably hit the water pipe before the pipe with the fiber. So just a stupid thing like that. There are very seldom any digging damages on a district heating based fiber network. We're also very into the security and robustness. So all telcos are very IT centric, IT heavy. But because most traditional telco networks are a patchwork of different legacy networks with different ERP systems, different way of doing things, it's a mess. Here is one network and is one ERP system. And that ERP system has been constructed and coded in-house by one guy. He's employed, not like on hours, he's his payroll. And that was Morten Bjørnes. He was supposed to be here today. He would tell you about how he has done this and what's the essence of the system when it comes to the data we put into it and what kind of insights and possibility we can take out of it. I'm a sales guy, so I think I will let him come to you next time and tell about it. But this system is creating some opportunities that actually mean something to you. And I will tell you a little bit more about that afterwards. Yeah, there's no active equipment in this network, so there's no issue with Chinese stuff, like the American stuff. There's no routers. The guy coding the system is Norwegian. It's hosted on Norwegian service in Norway. So these things matter to us. We tend to go extra mile to make things secure. Okay, so what the system could do. We can give you live routing on the fibers you actually purchase. That means you can always see where it is. Like, you know, the dark fiber network is dead, so it's not, there's no overwalking. Someone help me? Monitoring of the network. But we will show you where the routing is. That's possible here. So when you log into the portal, you will see where your routing is. And if we change it, you will immediately get a warning that something has happened. That means that you could plan your redundancy and diversity on this fiber network, and be sure that if we need to do something to move it, as soon as that change has come into our documentation system, and that basically takes, I don't know, 24 hours something, from something has been done in the ground until it's updated, you will get a notification. So stuff like that. That's, to my knowledge, impossible with traditional telco networks. If you ask about the routing, you will get a PDF. Technical guy made this for you, and he will go to the service manager, and he will go to the key account manager, and he will send it to you eventually next week. We can do pretty sophisticated analysis of the customer potential in an area. That means we can show you buildings, we can show you how many customers are located in that building. So we could work with your commercial side to make your sales efforts, your go-to-market strategies more functional and basically get more bang for bucks. So we can tell you where customers are located into geographies and into the actual buildings. That means something for the people planning how to sell, where to sell. Yeah, stuff like the OTDR readings, that's the quality measuring of the line you're purchasing. That's something you get in the library of your portal. So whatever line you have purchased, you can get this easy. And that's also something that traditional telco networks are not so happy to show you. All right. This is basically where we're leaving my familiar territory and going into the technical stuff. This is Jon Philip's presentation. I think I can just brush through the slides. I will not try to speak about things I'm not familiar with. The essence on this slide is that we build a lot of fibers. So the traditional networks are beginning to get a little bit out of date in terms of being full. I mean, they were built with maybe 48 fibers. That was a huge amount of fibers 20 years ago. 10 years ago, 96 fiber pairs was a lot. We tend to work with 288 size cables in most of the network. Even more, where we see that would be important to have a bigger inventory of fibers. All right, I will skip that one. This is the connectors. It's a good point from Jon Philip. He says that a lot of the traditional telco networks use the UPC connector type, and we use the APC. And it has something to do with how the light are going through that splice or that connection, making performance higher and being important for people concerned about quality. All right, going away this one. Documentation in our approach is always in-house, always with the people that knows the network. So it's not outsourced, it's not our contractors doing it. I think that's more and more common now, that all the telcos are using contractors to do that kind of boring work. We think that's insane. That this is the whole this is what makes you guys, or should make you guys comfortable with what you're purchasing. So if the documentation sucks, if something goes wrong, there's a breach because of digging or something, it will take hours to fix it, days if this one is not done properly. So we're very concerned about this, and we've taken this into the system architecture and this system that Morten was supposed to speak about. All right. Yeah, delivering dark fiber is not always the easiest job on the planet. It's very far away from your very challenging day-to-day work with all that magic stuff on the IP side. We are struggling with really, really low-tech issues. You see the manhole to the left? Guys were coming out trying to find the pipes in order to deliver for a customer, and some schmuck put some cement in the duct. So you can try to imagine how it is to reach your pipes and pull the cable through. So the right picture, we put a team with compressors and shovels and take the concrete out, and that's what it looks like under the concrete. So this is our day-to-day challenges. Very far apart from your day-to-day life. But if this doesn't work, the IP shuts down. All right, just some fun pictures from Oslo, trying to find new ways to get the fiber and the ducts from point A to point B. And we're even going nautical here. So I think this is on the east side, around an area called Grønland. It's one of the more shady parts of town. So yeah, but no, actually it is. So on top of this place, it's where they sell all the drugs, the retail of the drugs, and they have found dead people here. So like there's some, so they are floating around because there has been some deals gone wrong, and then you end up here. Okay. Yeah, right. So back to my initial challenge. I know that people around in this crowd are customers of us. We try to lead by example, so we don't spend a lot of resources on marketing. I mean, we do good stuff, and it's word of mouth, and our customers stick, and they talk to others, and that's how our philosophy to marketing and selling is. We're very proud of having several of the really hardcore companies as customers, and very humble that you decided to choose us, even at the point where we had a very small network and a very few people. We will not let you down, so we'll keep on doing good stuff. But if you guys or anyone else purchasing fiber, because everyone here has some kind of relationship to the fiber, has some idea that what could improve day-to-day life as a fiber user, shoot, and maybe we can have a discussion, or we can have it on over the dinner. Not everyone at the same time. Okay. Thank you very much. Sorry about the people with the flu. I told them to say hello, and that they would love to come another time and tell you about things they really care about. Yeah.
Thank you, Ola. You did a wonderful job covering for your colleagues. Next, we're going to hear from Florian Obser about DNSSEC. He's coming from RIPE NCC. And he's a senior system engineer there, where he runs one of the 13 root name servers, and as well as the auth DNS cluster for the reverse zones and various CCTLDs. He has been a DNS wrangler for 2 decades, and in his spare time he is an OpenBSD developer and experiments with DNSSEC validation on mobile devices. He will give an overview on why DNSSEC is needed and what it takes to deploy it in 2022. So let me just prepare. Yes. I think you can grab a mic and fix it meanwhile.
How do we actually move forward space?
Pardon?
How do I move the slides forward space on the keyboard?
I guess so.
Okay. Right.
Try it.
Nope.
Should be a clicker down
Oh,
there
yeah.
as well.
Sure.
Big button.
Yes, this works. Cool. Right. Well, I'm Florian. Thank you for having me here. I'm going to talk a bit about DNSSEC, but so this is not a training session or anything. So this is a quick overview to give you some terminology that you can then DuckDuckGo on your own to figure out if you want to do this. I think we can skip this. I've been introduced. So DNS. It's a globally distributed, scalable hierarchical database. And it's kind of the only one that we successfully deployed. It's around for decades, and this thing actually works. And it's so successful that everything on the internet uses it for federation, which means if I want to visit a website, I'm on ISPA, I want to go to a website on ISPB, this goes through DNS, so they need to talk to each other. Same thing, if I want to send an email, I need to look up the MX record for Gmail these days. This is all fine. When I want a TLS certificate, let's say I'm using the ACME protocol, I use Let's Encrypt. They go to DNS to find out where's your website, connect to the website, get a challenge. And if the challenge that I respond with is correct, they issue me a certificate, which has security implications. Then there are all these nice, I forgot my password. Maybe your bank does not do this, but there are a lot of websites that actually do this. So you click this, you enter your email address. Well, the website goes to DNS and figures out where do I need to send that email. So why is that a problem? And well, so luckily we're running a bit ahead of schedule, so I have more time about this. No, but seriously. So DNS has been around for decades, and back in the day, everything was nice and fluffy, and nobody cared about security, and well, that changed, of course, for some time now. DNS is, the data is kind of considered public. It runs over UDP, unencrypted, so everybody can see it, and an on-path attacker can change the data, so we don't have a data integrity there. It also uses caching, and there are things called cache poisoning attacks, which means that even an off-path attacker can mess with the data, which is not good. There are some protocols being developed to have the transport encrypted in DNS. So talk to a caching resolver over the encrypted transport. But we still don't have authenticated data origin, which means if I'm using an encrypted transport to talk to one of the public QuadX resolvers and ask them, where's ripe.net? And they come back, oh yeah, that's 2001:db8:42. Well, that's not actually the IP address. So I kind of maybe trust that resolver, but I can't trust the data that it actually hands me back. Maybe someone attacked it before that. And another thing, this is more a technical thing, you can also fake to say something does not exist, which also has security implications. And the last thing is there's no privacy in here and no confidentiality, but I'm not going into that. That's a completely different topic. This is DNS over TLS, DNS over HTTP, or these days DNS over QUIC. That's a whole different story. Now, how can we solve this? And people, again, decades ago came up with the DNSSEC. And what it does is it uses the existing DNS protocol, the hierarchy, the cacheability, and added public key cryptography on there by introducing a resource record for that, which is the DNS key resource record. And once we have that in place, we can publish signatures over the authoritative data. And well, so since DNS is hierarchical, we need to start somewhere with from where we validate the data. So if you're thinking of SSL certificates, you just have a huge list of trust these authorities, and this is rather flat. In DNS, this is hierarchy, so we need to start somewhere. Well, we do this in the root zone, where we also start with the DNS hierarchy. And this is called the key signing key of the root zone, which is well known. You can get it inline from DNS, but also out of band. It's published on websites, and it's also built in all resolver software. So this is not a concern to actually get that. It used to be a concern some years ago when DNSSEC was introduced, like you have a chicken egg problem. I want to use DNSSEC, but the root zone is not signed. My resolvers can't validate. So what's the point of starting with this? But that has been solved. I'm constantly going on about how this thing is hierarchical, so we also need to connect the hierarchies, which is the parent zone delegates. This child zone is allowed to sign things, and this is then again done with a resource record. And so it was specifically, DNSSEC was specifically designed to not be an online protocol because that would cause issues with caching. So the signatures are not calculated per query, but when a signature expires or the zone changes. Which means, yeah, we can actually cache answers, and not just on the authoritative name servers, but caching resolvers still work with this. I think I used the zoomed in version. So there's a tool, DNSWiz.net, which is can be used to debug this, and it visualizes how DNSSEC validation runs through the hierarchy. So I was talking about the trust anchor, the key signing key of the root zone. This is the thing on the top left. It's double circled, and it has this arrow going into itself. So this signs the DNS keys of a zone. On the left, this is the root zone. This is where we start. And it has two keys. It has the zone signing key and the key signing key. The key signing key on the top, and below that zone signing key, which signs all the other things in the zone, including the DS record, which gets us to the .NET zone, which is on the right. Again, the same hierarchy. We have the key signing key for .NET. Below that, the zone signing key, and below that, a delegation to ripe.net. And I will go into why there is a split between a key signing and zone signing key in a few slides. So this now shows ripe.net, and you will see there is only one key. There's no split, and this is called a combined signing key, and there are reasons why we're doing that. I will explain that. And so this key signs all the content of the zone, all the records that are in there, including the keys. So if you want to use DNSSEC How would you approach this? So what do you need? And it's not that complicated. You need to pay a bit more attention to your general DNS hygiene, things that you should already do with plain DNS. Make sure there are no lame delegations, which means the name servers that the parent zone hands out for your zone, they should actually be there and answer. And you should keep your name servers in sync. Like if you have multiple authoritative name servers, they should really have the same zone. With plain DNS, this is just annoying when this happens. They're out of sync. With DNSSEC, you can actually cause outages. And this gets really annoying fast. What's really important with DNSSEC is to have synchronized clocks, which means so the clocks need to be correct within seconds would be good. You need to have this on signing machines and also on validators, because the way this works is the signatures have an inception time and an expiration time. And if you think, or if your clocks say you're 1 year in the future, it will see all the signatures as invalid because they're too old. So that will not work good. This is not a requirement that you have with plain DNS, so this is a new thing. People really like to ignore TTLs in DNS. And this causes a lot of issues already with plain DNS. You think it works like this, and it turns out, no, it's not. Like, oh, I changed this record, and yes, but it's cached on all the resolvers in the world, and it will only fall out of there in a day. With, again, with plain DNS, that kind of works. It gets really painful with DNSSEC. And especially, you need to pay attention to that TTLs in parent zones are usually very long. So if you're making a mistake, you need to fix something, you signed something wrong, and this has something to do with your DNS keys, or maybe you lost your private key, which means you need to go to the parent zone and switch out the DS record. But this one has a TTL of a day, which means you're offline for a day, which is rather annoying. So don't do that. And so I was already saying that the signatures have an inception and expiration day. And so if you have your authoritative name servers, say you're running this as an Anycast constellation and they're all over the world, you will eventually lose access to a name server, so it can't talk to the signer. It will fall out of date. The start of authority record in the zone specifies how long that name server is allowed to hand out that zone. And that should be shorter than your expiration time of the signatures. So if you're, say your signatures expire in a day, and the SOA record says, oh, the authoritative name server is allowed to serve this zone for a week, then it will happily serve this zone for 6 more days and will hand out expired signatures. But if you turn this around, like the signatures expire in 6 days, but it's only allowed to hand this out for a day without contact to the signer, after a day it will just answer serve fail, and resolvers will just go to a different server. So people actually got this timing wrong. People actually got this timing wrong in the root zone. So it never causes issues because things did not actually expire, but something to pay attention to. When DNSSEC was introduced, people were really scared about this because with DNS you can launch an amplification attack, especially since this is oh, sorry, I'm jumping ahead. Well, I can just do that. So, yes. So with DNS, since it runs over UDP and you can easily fake source IPs, you can launch amplification attacks because the query is usually much smaller than the answer. So I'm spoofing an IP address, send a query somewhere, and the big answer goes to the target. Now, a problem with DNSSEC is that actually the answers are even bigger. and it was thought that this will cause a problem. It is not as popular anymore to actually do this. I suppose people just have more capacity and don't care about this. A good solution to this is also response rate limiting, which all name server software has enabled, as in, oh, it's the same query coming in over and over and over again. Yeah, I'm not going to answer that. Crypto also got better, so we can use elliptic curve cryptography, which generates considerably smaller answers than RSA. And we're going to talk about NSEC versus NSEC3 in a moment, and NSEC, I'm jumping ahead here, generates also smaller answers than NSEC3. Another issue with, I'm jumping now to the top of the slide, with large answers is IP fragmentation, especially with IPv6, because routers on the path can't fragment packets in IPv6. So if you have an MTU problem, the answer will just be dropped on the floor, and there's no way to do a retransmit or anything. This is all UDP. It's just a query response. This has also been mostly solved if you run a reasonably modern stack of software. There was a decision in 2020 by all the major vendors to set a limit on UDP packets at 1232 bytes. There's still a discussion if this is a good number. It's basically a random number that works. But what the exact good number would be is still open for discussion. But I don't think that's too important. Like, okay, for operational purposes, this works. If your answer needs to be bigger, there's something in the protocol that will upgrade the UDP protocol to just redo the whole thing over TCP, and then you don't have any size issues anymore. So this is all solved problems. So you want to do this thing, then you need to decide on a few more things, as in what kind of crypto do you want? And these days the choice is basically between elliptic curve and RSA. There's an RSC which says the following algorithms are supported as a signing or as a validation, and it comes down to these two algorithms are what you have available currently. I'd shown about the KSK ZSK split, a key signing key and a zone signing key versus a component signing key. These are the trade-offs. If you split the keys, you can keep your key signing key offline. And because you only need the zone signing keys for actually signing operations, and when you need to, if you want to roll your zone signing key, you wander over to the vault, open the vault, get the key signing key out, assign a new set, and hand this over. And then you lock the vault, hopefully, again. And the upshot with that is that, so the when your zone signing key gets compromised and you need to roll this, you can do this rather fast because you're controlling the TTL. So if you want to prepare for this, you have a TTL for, let's say, an hour or maybe a few minutes, and it will go that fast to rotate keys. On the other hand, so these are more moving parts, and so I was also then showing that for ripe.net we're using a combined signing key, and the reason for that is, well, the zone is smaller, we have fewer moving parts, and the way we have this set up, the key signing key is online, so there is no actual technical split, so it's completely pointless to have this then split in the zone. The biggest downside is if you need to do a rollover, you need to interact with the parent zone, and I talked about this before, TTL 1 day, it takes a day, well, actually it takes longer than a day for a rollover. One of the things I talked about that DNSSEC promises to fix, and I had also talked about NSEC and NSEC3. I had mentioned this shortly before, as NSEC produces smaller signatures. So how do I, with an offline protocol, how do I show that a thing does not exist? How do I have a signature that a thing does not exist? Now what I could do is I can produce signatures for all the things that do not exist in a zone, which means that zone would be pretty big because zones are usually sparse. So here's a trick to do that. Since the zone is sparse, what we can do is we can sign nothing exists in this interval. So say I have a.example.net and c.example.net in the zone, and someone asks for b.example.net. Then I will answer with nothing exists between A and C. B lands in the middle, nothing exists in between. So we can sign this. Obvious problem with this is I can trivially enumerate the zone. So this makes the zone public. Because I can just follow those intervals, like, okay, there's nothing here, then, oh, there's something there, is the next one there, and so on and so on. I get the whole zone. People thought this is not actually optimal. I want to keep my zone private. So ANSEC3 was introduced, and it works the same way. It hands out the interval, but the labels are actually hashed. Turns out, well, you can just do a dictionary attack against that. And this is an offline dictionary attack, so you don't blast the authoritative name servers all the time. There's a way to just get all the things out, and then in your own time, you do a dictionary attack against it. And people have done this. Also, probably your zone is not that interesting. You probably have a mail.thing in there and .thing, and well, you can work this out. People still want their zones private, and what you can do there is what's called white lies. So what you do is you just hand out the minimal interval of something that does not exist. Say I have a.example.net and z.example.net, and again I asked for b. So I don't get an interval a and z. I still hand out again the interval. I say nothing exists between A and C. The downside with that is this requires online signing, so it loses all the. I have pre-signed my zone, and I don't need any crypto on my name servers. But you cannot actually learn anything about the zone except you're doing a brute force against the zone. Like ask for all the things that could possibly exist, which is not particularly interesting. You can also do this with plain DNS, just ask for all the things. And people will notice this. If you blast a name server with a few million questions per second, people tend to object to that. So it made all these operational decisions, and then you need to actually start signing a zone. And yeah, when we started with this, this was a fiendishly clever Perl one-liner, and yes, I operated one of those. Luckily, these days you don't need to do this anymore. All the open source software has you covered. So if you're using one of those solutions, you can just toss a switch, and it will happily sign your zone with various levels of convenience. So you don't need to switch your software stack for that. How do we design this? And this is just an example of how we are running things at RIPE. And I think this is a reasonable generic design. So you have some sort of database where your zones are stored. We have multiple sources of truth at RIPE. So for the reverse zones, this comes out of the RIPE database. And we also have, like RIPE.net itself is managed in Git. So this is then fed into a hidden signer, and we have two of them. The other one is a warm standby. So it it also gets the zones fed in, and it also signs the zone, but not with the actual production key. So we can monitor both of them, that they're actually doing the right thing. And on an update, a zone gets updated. The hidden signer signs the zone, sends a notification to two distribution servers that are in diverse locations. They do a standard AXFR to the hidden signer, slurp the zone in, and then notify themselves our Anycast cancellation, which is all over the world. And they then do an AXFR to the distribution servers. And here is also an upshot of DNSSEC. When your zones are signed, you don't need to trust your DNS provider that much. So say you run your own DNS servers, but you also outsource this. And you have a provider for this. You hand them your zone. But can you actually trust them that they hand out the correct data? And what we're doing at RIPE is we basically ask the community, do you want to host an instance? Here, go ahead. Go to this website, which is hostedDNS.ripe.net, and apply for this. And we happily accept this. And this is doable because the zones are signed. So someone can't hand out a fake zone because people are actually validating this. This will you will be able to spot this. With plain DNS, it will be very difficult to actually spot this if this happens. And this does not need to be malice. It could also be a hardware fault or a flip bit here and there. You can also detect those things. Right. So you have this. Oh, I should go back. Now, maybe you don't have this Anycast constellation. Maybe you only have two authoritative servers. This is something that is reasonably complex, and so if you have just two authoritative name servers in diverse locations, that's good enough. So maybe they talk directly to the hidden signer then. So things just stop here. You don't have this bit. You don't need to. So you have your design set up, and you're signing your zones, and now you need to publish this DS record to get the connection from the parent zone to your zone. And this works by talking to your registrar. This is either you go to the website and you need to put in things manually, or various registrars came up with their own API. There's no good standard yet. So if you know a bit about domain provisioning, there's the EPP standard. You sometimes can use that. But yeah, you usually don't get access to that. So all the APIs that you will find out there is some webhooks kind of thing, and it's different for all the providers, which is a bit annoying. There's a protocol specified at the IETF, with which you can provision DNSSEC inline. You're publishing a CDS or CDNS key record, and the parent zone checks this once in a while and pulls that out there and converts this into the DS record. For the reverse zones at RIPE, we support this for key rollover. So you can't use this for the initial provisioning, but you can do this for key rollovers. So you have this all set up, and eventually you will make a mistake. And the best advice I can give you is step away from the computer and panic, because you're going to panic anyway. So do it somewhere where you don't cause more damage. Once you're done with the panicking, figure out what the hell went wrong. And there are tools for that. So I had shown the screenshots for DNSWiz.net. This gives a graphical representation. It usually has an exclamation mark somewhere, this went wrong here, and then you need to dig in why that went wrong. If you're more into a text representation, there's the DNSSEC analyzer from VeriSign, which walks down from the root zone and flags things that are wrong in a text representation kind of thing. If you're more on the command line, there's dig, which you use to debug DNS. So you can also use this for DNSSEC. I like to use these flags. So plus DNSSEC enables to ask for DNSSEC records. Multi-line formats this a bit nicer. And no crypto, it gives you all the DNSSEC resource records, but it leaves all the crypto gibberish out. So it's just liners at that point, and you're not going to do the math in your head, so this is not actually interesting to you. But it will give you the expiration dates of the signatures, for example, just not the actual signature. Another tool also by ISC is Delve, which kind of does what the DNSSEC analyzer does, as in it tries to verify your zone by walking, this one actually walks up to the root zone and tries to figure out, oh, the validation went wrong at this point, and gives you hints why that went wrong. And then there's DNS.org, which is a community of DNS operators. They have the DNS operations mailing list. I think it's a good idea to be subscribed to that. And they also run a MetaMask server where all the DNS community is welcome, and there are certainly knowledgeable and helpful people in there. Now, we were only talking about signing and putting these things on your authoritative server. You also want to actually validate this, and the good news is that all the public QuadX resolvers do validation. So a lot on the internet does validation already, and if you want to run your own resolvers in your network, open source software again has you covered. They all do this. A few considerations when you operate such validating resolvers. Again, you need to keep a proper time, and which means synchronized clocks, which means NTP, and NTP depends on DNS, and you have DNSSEC enabled. So if your time is off, DNSSEC fails, and then you can't synchronize your time because it needs, don't do that. Like, make sure that your NTP servers or that your validating resolvers use something else to get DNS answers. Like, don't point a name server 127.0.0.1 in your resolve conf so that it talks to itself. You won't get out of that loop, at least if your server comes up with the wrong time. So if you expose this to customers or in your own company, you want to start monitor the serve fail rate on the resolvers. So all the open source software showed they expose some sort of metrics, and if you suddenly see a spike in serve fail, that usually means that someone out there made a mistake in finding their zone. Or if this is all over the place, you probably made a mistake, as in maybe you don't run on proper time. And then it's time to investigate this, why is this failing? And if it turns out that someone out there made a mistake, and this is really important, like it's a website that you really absolutely have to reach. And you have, so they're using DNSSEC, you're validating, you know they made a mistake, then you want to be able to tell your resolver, yes, it's okay, just give me the answer. And that's called negative trust anchors. So this is what you can look for in the documentation. This is, yes, okay, you can hand out an answer for this domain. And you just list all the domains where you think, yeah, it's fine. And probably once they fix their mistake, you pull them out again. Now with authoritative name servers, they're network-wise, they're usually in a pretty good location. You don't have any network issues. With validators, sometimes there are weird middle boxes in front of it. Think of a CPE at home, and someone has the brilliant idea of running a validator behind it. And the CPE has opinions on how DNS should work, as in it's UDP and it's 512 bytes, which is wrong since, again, decades, but well, these things think about this. And they will just drop DNSSEC records on the floor, we'll just ignore them. Or what I've also seen is they just answer NX domain, as in this thing does not exist for all the things, which is also brilliant. So Or if you're in a data center and you have a really weird and ancient firewall in front of it, it might also have opinions on this. So maybe update it or at least check that it does not do stupid things there. What? There was one last slide which it does not show. Anyway, that was it. Do you have questions? Yes.
I was wondering about the CDS and CDNS key.
Yes.
Is that something that's universally supported, or is that just some CCTLD section?
It is unfortunately not. So the question was about CDS and CDNS key support. This is a new thing, and it is not universally supported. There are a few CCTLDs that support it. I think the Swiss, everything that's operated by the Swiss registry, so this is .ch, .lu, and .li, I think they support it. We supported a drive for the reverse zones, and I think there are a few registrars that also support this. So the protocol is usually between the child zone and the parent zone, but you can also do this on the registrar side, where the registrar queries the child zone and then talks to via their normal channels to the parent zone. I suppose that's the way this is going to be universally deployed eventually.
It's not on .nl, you know?
I don't think NL currently does it. No.
And then there's another question about that, because you're using the integrated signing key.
Yes.
Common signing key or combined?
Combined, yes.
So .NET does not have the CDS.
Yeah.
So when you roll your keys,
Yes.
do you do that as a manual operation, or do you have an API for that, or do you just not roll your keys?
No, we roll the keys once a year. So we used to roll the zones. So we used to have the split key signing key, zone signing key. We rolled the zone signing key once a month, I believe, or maybe every 2 months. And the key signing key was rolled once a year. It is a manual operation in the sense of we're using NOD as a signer, which has signing policies which would do this automatically. So you can tell it to do this once a year. Actually, I think we have this enabled, but then it stops. So it starts the signing operation, and we get an email. The signing operation started. You need to now send this up to the .NET zone, for example, for RIPE.NET. And we have an API call for that, yes. We also have, there's also an API for the reverse zones when we need to talk to ICANN for that. And there's a completely manual process for E164.ARPA, where you need to actually send an email and wait a week to get an answer. Yes.
Thank you.
Any other questions? No? Well, then, thank you.
Yes, thank you very much, Florian. I will be compensated for the technical content. Yes. Next, we will be hearing from Ola Thuresen from NLogic about EVPN and VXLAN to replace legacy technologies. Ola has worked at NLogic for 8 years as a senior network consultant, where he's mainly working with ISPs, but also a lot with optical and some enterprise networks. He is also holding courses, including some quite popular IPv6 courses. So welcome, Ola. Thank you. Set your, I think you need to take the mic. Ska höra dig online. Ja.
Yes. I was supposed to have. Well, I can start to. I got a short introduction here, but I've been working quite a lot with EVPN and VXLAN lately because while for many it sounds like or is known as sort of technology that is used mainly in data centers, we see that it's used more and more also in other places and other kind of networks. So I'm going to talk a little bit about that. I was supposed to have pretty short time, and anyone who has tried to read about EVPN and VXLAN and learn it knows that it's a very, very big topic. So I was supposed to have 15 minutes between you and lunch. So this is going to be very, very high level. I'm not going to talk about the details here. What I want to talk about, what I wanted to sort of focus on here is to replace old legacy vendor lock-in, stacking, or virtual chassis, or whatever you want to call it, technology to interconnect switches, basically. Because that's one of the places where we see more and more use of EVPN VXLAN instead of using the vendor-specific stacking technologies. So, what's the problem with this kind of stacking? First of all, it's obviously a proprietary technology. Cisco has one kind of technology, Juniper has one, I guess Huawei has one, I guess all the vendors have different technologies to stack switches together, which again mean it's kind of vendor lock-in. You only can use switches from one vendor in a stack. And probably also only specific models. You can't just pick and choose whatever you want. You need to be very specific in what kind of models you can use to build a stack or build a virtual chassis or build a, what they call it. And you have some scaling issues because there are probably limitations. Some models only support maybe a stack of two. Some might support a stack of 5 or 10, but it's obviously a scaling problem. So there are lots of problems with this kind of technology, with the old stacking technologies. So why do we do it then? First of all, it's easy to set up. Usually it's very, very easy to set up. You might just connect a couple of cables and it's working out of the box. And the other main reason is that you have fewer units to configure. Instead of configuring 10 switches, you have one routing engine to configure. And it will spread the config out on all the switches. So you get more interfaces with just fewer boxes or fewer logical boxes. But what we need to consider when I say that we should at least think about replacing this with other technology is what's underneath these 2 points. First of all, when we talk about that it's easy to set up, we need to think, how often do I really set up a new stack? I mean, it could be very easy to set it up, but if I do it once a year, it doesn't really matter if it takes 2 minutes or 20 minutes to set up a new stack or to create a new stack. And the other question, obviously, is how much work is it really to use some other kind of technology to do the same? Because if it takes 2 minutes to set up a legacy stack and 2 minutes to set up a more open stack, then not open stack, but open stack with open technology, then it doesn't matter. So why should I use the vendor lock-in proprietary solution when I can use an open solution? And the other question was, yeah, you get fewer units to configure, and that's obviously right. But there's one keyword here that's so important, and that I think everyone is working on it, and those who are not working enough with it should work more with it, and that is automations. Because automations is the key, not only to this, but to everything. Automations, while it might lead to bigger errors spreading very, very fast throughout your network, in general, it also leads to fewer problems, fewer errors, less issues in your network, provided that you have the right tests in place before you roll out automatically shut down all ports in every network device script. But if you do it correctly, automation leads to better customer satisfaction, fewer problems, and a better network health all over. So that's key, not only to this, but with automations in place, it doesn't really matter if you need to configure one stack or 10 single switches, because it's all automated anyway. So what I'm suggesting is that we should at least look into replacing those third-party technologies with a solution based on EVP and VXLAN. I guess lots of you know a little bit about it. Some of you might know a lot about it, maybe even more than me. But I'm going to go through very high level what is this actually, and how hard can it be. So what is actually EVPN and what is VXLAN, and is it as hard as many people think? Because if you look at it, it might look very hard. First of all, what is EVPN? EVPN is use BGP to learn MAC addresses and MAC IP bindings. BGP, well-known protocol, very easy to extend, and has been extended to be able to provide or to announce MAC addresses, not only IP addresses and IP networks. So it's just a BGP session where each switch learns the MAC addresses on the other switch, and is then able to know that, all right, if I want to reach that MAC address, I need to communicate. I need to send my traffic to that switch. But how it's going to do that? It's going to use VXLAN. And VXLAN is basically just layer 2 over UDP. So again, not on a high level, not very difficult. All you need is some kind of layer 3 connectivity between the switches. They send UDP packets to each other, and you have a layer 2 tunnel over UDP. An additional good thing about VXLAN compared to VLANs is obviously that you have 16 million VNIs, virtual network IDs, whereas you only have 4,000 VLAN IDs. So suddenly you can have lots of more VLANs in your network, and you can do fun things with VLANs that you couldn't do before. I don't really suggest building huge layer 2 networks anyway. I love layer 3, but at least if you need to transport layer 2 somewhere, you will only have a layer 3 network below, so you don't have all the big layer 2 domains with all your spanning trees and all your loops and all your problems anyway. So the EVP and VXLAN means that you have an underlay and you have an overlay. The underlay is just used to discover the members of the EVPN. And the overlay is used to exchange the traffic. So all the switches that participate in a specific EVPN, they need to know about each other. So that's done by the underlay. It's just to find the other members. And then you use the overlay to do the actual transport of the data. It could be MPLS. I'm going to talk about VXLAN here today because it's easier. But there's also EVPN over MPLS, which is an option if you want to do that. Right. So that's the base of the technology. Not going to go much deeper into it than that. You can ask me in the break afterwards if you need to or if you want to. How hard can it be? Well, the underlay is very simple. As I said, all the underlay is doing is to ensure that the switches or the members of the EVPN can see each other. So there need to be some kind of routing because it's layer 3. So you could use just a static route. If you have 2 members, you can use a static route. They need to find each other's loopback addresses. Usually you would use another protocol like OSPF for BGP because you can extend it a bit more. But it's just the important thing is that the loopback addresses of each switch can see each other. That's all you need to focus on to get the underlay up and running. The overlay, also pretty simple. Since this is BGP, all you need is you need to have iBGP between the members, between the loopback addresses that you discovered in the underlay. And BGP is used to exchange MAC addresses to signal the EVPN. So this is just BGP sessions, loopback to loopback. You can use a full mesh if you have a small network, or you can even use route reflectors if you have a bigger network. So not much to set up, quite easy, and to get it running doesn't take that much time. Basically, that's to get the overlay up and running, and to get EVPN up and running. Here we have 2 different vendors. That's basically all you need to do. I say basically because obviously there's more to do than that. But you need to have BGP signal the EVPN, and you need to encapsulate the EVPN traffic into VXLAN. So on a high level, it's very easy. Of course, you can dig a bit deeper. The Juniper book on EVPN VXLAN is 2,331 pages long. So there are a bit more than those 2 knobs. Cisco has specific for the different devices. This one is for one of the catalysts. It's 654 pages long. So there are lots of details, lots of stuff you can learn, and some of it you should learn. You don't need to know all of this to actually deploy it in a simple way. But there are lots of details, and especially when you start using multicast and stuff inside an EVPN. But to get it to replace some kind of stack of virtual chassis, you don't need to know everything in the 2,331 pages long book. Actually, when I set it up, I think there's 4 lines of config on a Juniper switch, in addition to the BGP config to get the underlay and overlay up and running. So you don't need to know all of it. You should need a bit more details too, because there are things you can tune, of course, and how you can do things. And as things grow, it will be more complicated. But it doesn't have to be very complicated. And that's very important because, as I said, I know that many people, they have seen these books and they think that, all right, I'm not going there. I don't have time to read 2,000 pages. But you don't need to do that to set up a simple solution. So what you get with an EVPN VXLAN solution to replace a stack, you get 2 or more, obviously, individual autonomous switches. There's no shared routing engine, but that also means that there's no fate sharing. So if one of them goes down, doesn't matter, the other one is working. If one of them needs to be upgraded, no problem, it can upgrade and all the traffic will flow over the other one. They don't need to be the same version, they don't need to be the same, they don't even need to be the same operating system or the same vendor in theory. As with all technology, I would do a good interrupt test before I started deploying this with one Cisco and one Juniper and one Huawei, of course. But it is BGP, so it should work pretty well. And also it's very easy to extend or to modify, because it's simple BGP config to add another box to your stack. As long as it has layer 3 connectivity with the other ones, and you get BGP up and running, well, your stack can grow without needing to connect new cables or anything. Layer 3 in the bottom and just add another host, another switch. So that's what you get from it. And what you get for your clients, uplinks and downlinks, they're the same as if you had a stack. They can just use simple link aggregation, LACP, down to your clients. They have one uplink to one switch, one uplink to another switch. The switches don't really know about each other, or they know about each other over the EVPN, but they don't. The client doesn't know that it talks to 2 switches, and the 2 switches share the MAC addresses using the EVPN VXLAN and the traffic. So from the client's point of view, it's just one switch. So you don't need to modify anything either on your client side or on your uplink router side. So you can connect 2 or more switches without worrying about the rest of your infrastructure. What do you lose then? Well, as I said, you now get autonomous devices, so they all need to be configured individually. If you just have a two-member setup, which I have in most of my cases, it's just a two-member setup because the customer wants two switches, all the clients connected to two different switches, and those switches connected to two routers again. Then I have exactly the same, except for the IP addresses, config on both switches. So it doesn't really matter that I need to configure them individually. I need to paste the config twice instead of once, or I need my automation tool to run on two switches instead of one. Of course, if you add more members, you can add a huge VXLAN. You can add all the switches in your network into the same EVPN VXLAN solution. Then it gets more complex, but you also gain more flexibility. You can connect one host to switch A and B, and another host to switch A and C, and a third host to B and D, and it will all work as one big virtual switch on the layer 2 level. But you don't get all the loops, and you don't get all the spanning trees, and you lose all of that. But again, to get this working, automation is obviously the key. Just want to tell you a short story here from about a couple of weeks ago when I was working with a customer. They have a big VXLAN. Big EVPN VXLAN setup, and crossing multiple data centers all over Norway. So I was working in one of the data centers, connecting some hosts, and they were supposed to set up the routers in the same data center. So I was working on the client side, and they were working on the router side. And suddenly, after we've been working for a couple of hours, I just thought, whoa. And he discovered that he had configured all the routers in a completely different area of Norway, in a completely different data center. He just didn't know where he was logged in. And it worked perfectly because the whole layer 2 network spread out the MAC addresses as they should. So when the routers in Trondheim wanted to find the MAC addresses for the clients in Oslo, well, they found them through the EVPN VXLAN. So you can build a very, very big network here, and all they needed to do was to add the VNIs to the Trondheim routers, and I added the VNIs into the switches in Oslo, and everything was up and running. We needed to take that down again because I didn't want the network to work that way, but it shows that you can build this up to a very, very large scale, and it actually works. So with that, I'm saying no to proprietary stacking and yes to EVPN VXLAN. And that was basically all I had. Thank you. Any questions or any comments? Please come see me in the breaks if you want to. Either on this or other topics.
May I add a suggestion?
Yeah.
Can I say yes to EVPN over segment routing instead?
You can.
Segment routing is never the answer. PC member of many PCs.
That's a perfect discussion. And should you use segment routing over IPv6 or segment routing over MPLS?
Right. Thank you very much. Thank you for the details, and yeah, closing in the gap to lunch. So now it's lunch, which will be served just here behind us, and we will resume here at 1 o'clock exactly. Thank you very much. Yes, I hope you had a nice lunch. It sounds like that. We are now ready to continue with the second half of the day. We have 4 interesting talks going on with a bit of break in between. So first up is private 5G networks with Hemdan Bezavih from Telia. She works as a business developer for Telia Next. She's been working in the industry for over 10 years, mostly with designing base station and optimizing mobile networks. As technology is becoming increasingly ingrained in all the customers' processes, she has chosen to work closer to the customer to understand their pain points and opportunities for improvement. Currently, she is working as a business developer in Telia Norway with special focus on coverage, 5G, private networks, millimeter wave, and she is passionate about technology and all the possibilities it creates. So, please.
Thank you. Hello, can you hear me, all of you? Thank you for having me. What a great introduction, Marius. I'll talk about private networks I'll share some customer insight, our strategy in Telia, and I'll go through some use cases. So let's just start with the backdrop. We're upgrading our mobile network, so we're getting rid of old technology, some legacy bands, and we're installing new base stations. We're adding 4G, extra capacity on 4G, and we'll have 5G all over. And also the transport network is being upgraded. So we've done this a couple of years now, and we should be finished next year. And while we're doing this, we've been also investigating all the possibilities with 5G. And I'm sure you all know with 5G, we're talking about low latency, high throughput, connecting millions of devices to a network, slicing private network. And for the regular person, 5G may not be that special. You get the speed, we can handle more traffic, so less possibility for saturation of the network. But the most interesting aspects are the advantages of 5G you'll see in the industry. So 5G and private networks is seen as an enabler to increase digitalization and automation in the Industry 4.0 vision. There's the last couple of 2 to 3 years, there's been a lot of activity regarding private networks. At the beginning, it was just a buzzword. Nobody actually knew exactly what the customer need was or how this would look. And then there have been a lot of pilots. And in the last year or so, we've seen paid customer cases. And we've in Telia experienced that people or customers are coming to us and wanting to know more about this and wanting to test this. And a lot of the companies know a lot of private networks and 5G and what it entails and gives, and some don't still. So in Telia, we launched something we called Enterprise Mobile Network, which is a portfolio of different products, including private network. I'll go through that later. And in this year, or the last 1.5 years, we've been testing and selling private network for different customers, and also in Telia company or in the Nordics, we've had several cases where we've delivered private network. And I can add that there are specific frequencies allocated for industrial purpose, also available for testing. So if you're a company that wants to test private network and manage it on your own, that's possible. So I'll start with the customer insights. We've used a lot of time to understand what the pain point is, what the customer's pain points are, and what they need and what they think about 5G. So what we see the drivers for using 5G in private network is, this is some of the highlights, but the guaranteed quality that you can get, the enhanced security, low latencies is exciting for some use cases, that we can support massive IoT, and that you have increased capacity indoor and outdoors. That's also exciting part of 5G. You can get all of this both indoor and outdoor in the national network or in our macro network, or through a private network, for instance. Some of the companies that we interviewed, it was an interview, and they said that data processing and how the data is stored is very important for them, and some of them want to find a substitute for Wi-Fi because of some instability issues, and the coverage on Wi-Fi is not always optimal, especially in an industry setting. Yeah, sorry. And then we asked about use cases. What kind of use cases would need 5G in private network, and investigated that. These are the top 5 or 6, 7 use cases. But you see that AGV, smart connected equipment, video analytics are some of the use cases that will really need 5G. And that fits with our thought around 5G. We're thinking, as I mentioned, we see 5G and private networks as an enabler to really automate and connect everything you have to a network, and then use automation and AI and whatever on top to effectivize a production or an operation and make better, faster decisions. We asked the customers, would they want to do this themselves, or would they want the operators to do this? Do they trust the operators to do this? And there were, most of them said that they would like this as a service. They don't want to handle it themselves. They want to focus on what they're good at, and they want this as a plug and play. But you do have some companies that wants to handle the private network on their own and handle the whole connectivity. So based on this insight, we made this portfolio with 3 products, and it's a portfolio that will grow as new technology emerges or are tested. So I'll go through these: private network, hybrid network, and virtual network. That's what we have today. So what is a private network? The word says it all, maybe. It's a mini mobile network on a location, on a premises. In this picture, you see a platform. It could be a platform where you have, there are specific SIM cards provisioned to work on that core. And if you move outside the coverage area, you won't have access to any connectivity, and also not the data that is that exists in the platform. I mean, physically, it's a box with some servers, and you have core and baseband units, and the RAN with antennas and cables are connected to that box. You will get local survivability, meaning that whatever happens with the macro network, the private network will still work. That's very important for some of the use cases and companies. You can use our spectrum, or you can use industrial or spectrum allocated for industrial usage. You'll have ultra low latency because of the data does not move outside the premises. So in addition to ultra low latency, you'll also have this high security because everything is on site. So yeah, and I said the point about mobility, that can be an advantage and disadvantage. Some companies like that, that if someone don't have access to the premises, they won't have access to any of the data floating in the platform or whatever. While some of them think that it's a disadvantage because you do want to move outside the area. There are some industries that private network is maybe sufficient or is fitting. Mines, ports, offshore installation, manufacturing industries, and so on. A lot of the pilots that we have seen is private network pilots. So the next is the hybrid network. It's a combination of a private network and the services found in our macro net. You can set it up differently, but for instance, you can set it up using a local breakout, meaning that the data is on premise. It doesn't leave premise, but some of the signaling goes into our mobile network. So you'll get the security. The data is only locally available. But you can also move outside the coverage area of, for instance, a hospital. You can move outside the hospital and still have access or still have connectivity, but maybe not have access to all of the services that you would have if you were in the hospital. We can add with customer-specific coverage, and we can build redundancy. We can add edge compute and everything on top of this. And on every product, we do deliver quality of service. The third one is something we call specialized services in the macro, which mostly is a virtual network. Similar to a VPN through 5G, but you can also get that with a slicing. We have a private APN if needed, and we can add with the coverage, quality of service, or an SLA on the quality, and we can also give the customer prioritized access on the SIM card. Yeah, and this service will then be accessed wherever you are in our network. So these are the three products. So what is the Telia's strategy for delivering private network and enterprise mobile network? We will deliver it as a service. That is what the customer wants. It is expensive, so for most customers, one-time sum is too much. So they want it as a service, and they want it to work. We have to move from a best effort solution to a guaranteed service quality. What you get in our macro network today is best effort. Everyone has the same access, the same performance, but using private network or slicing, you can guarantee quality. We'll have a dedicated control center for these products, and we can deliver it on our own spectrum or the industry spectrums that I talked about. So over to the use cases. We've talked to different industries, and there is a growing interest for these products. And I'm not going to go through all of them, but I picked out some of the use cases that we find most interesting and that we can talk about. So the first, I don't know if you know this, but Sporveien, they have a CBTS system, a train control system, where that controls all the trains. And the standard solution would be to use a proprietary closed system for the wireless connectivity. But they wanted to use the macro network, or one of the operators' network. And we won this contract, and they needed a robust and reliable connectivity. And what we chose to deliver, or what we are going to deliver, is a virtual private network. And the data link will be integrated to their system. And we are customizing both the RAN, and we're delivering SLA on, for instance, round trip delay. So we have to guarantee availability, we have to guarantee round trip time delay, round trip delay. Because if something goes wrong, the train stops and they lose a lot of money on this. So it's very critical that everything works. The service will have access, prioritized access, so that if there's a lot of traffic, we know that this will go through. And the solution can be extended. So for instance, Fornebubanen, when the metro is extended, they can use this. We can deliver that on every strekke. So that's one of the use cases that are very exciting. We've delivered private network for at an open mine, at open pit mine at Boliden, Aitik, I think it's in Sweden. And they wanted to automate the drilling operations. They wanted to connect everything on site to online. So the trucks and all that they have, and they have estimated that they can save millions annually by doing this. But they needed something robust, reliable. They needed something that worked outside and in tunnels. So we delivered private 4G private network, actually, which is ready to be upgraded to 5G. And we have built a dedicated RAN. We are delivering push-to-talk services, and of course an SLA on availability and the service. Another one, Njord-plattformen. It's a platform owned by Equinor, and the platform was undergoing some work in Stord, and it was going to be placed, anchored as 5.9 kilometers from land. And they wanted the connectivity, or they wanted workers to experience, to be able to work as if they were on land. So so there were 50 to 100 workers, and also sensors and other equipment. So we gave them customized coverage. We had equipment on the platform and also on our base station. And we delivered IPVPN services on 5G as a backbone. And there was redundancy and SLA on the whole solution. So this is a virtual private network solution. And they tested a couple of weeks, and I think it was 20 terabytes of data that went through our network. So a lot of data, almost 1 terabyte each day. And they were really happy about this solution. Another very exciting project is defense. Our Norwegian defense is really ambitious, and they want to buy a tactical private network that they can move and transport and operate autonomously whenever they need. And they use a NATO spectrum, so we had to be able to deliver that. It's a joint project with several operators, and it's a pilot project. So they want to just test a private network with different operators. And it should be the solution should also be integrated with the Telas macro network. So they want access to the macro network and a private network, and the objective is to buy a managed service in 2024. But we are working with that right now, and we have a portable private network that they can just take and start using. And we're also going to deliver a defense slice and their own slice in our network. Yeah, another exciting SIP project, Herøya Industry Park. It's a park with a lot of big companies, and they had an ambitious plan. They wanted to build the most advanced testbed for 5G and private networks in Europe. And we've started a collaboration there to deliver this. And they want to test it all. They want to test private networks, edge computing, virtual networks, and they want to make this available for their tenants. So this is also one of the projects that we are working with now. And last but not least, we do have a 5G lab in our own headquarters to be able to test the equipment and invite customers to test it. So here we test. We have a private network, a millimeter wave, other technologies that comes up. We can test and showcase. So that's it. What is?
Yes. Thank you. Questions? You're talking about having 5G instead of Wi-Fi. What do you think about indoor coverage? How do you plan to build it?
How we're planning to build indoor coverage? I mean, if they want to substitute the Wi-Fi, we have to build the indoor coverage, right?
Yes, but would that be for the, let's say, in an industrial perspective, a plant or something? Do you want the customers to build it, the infrastructure, or would you build it, or who will build it?
In Norway, there are different models. So the operators can build it, or we do have entrepreneurs that we collaborate with, a partner network, that can build the indoor antennas and cables, and then we can install the base station afterhand.
So we have to do a large build-out for the industry.
Yeah. And it's something, it's a paid service, if that's what you, so that it's the customer that, if they want to.
But this industry spectrum we are talking about, is that, do you need to have concession for it?
We don't have it. It's still on trial, I think. So you can, as a company, you can apply to use to test the frequency. And then you can either buy your own private network and install it and test the frequencies, or you can collaborate with one of the operators.
Yeah. And in the beginning, you said you had already a testing project which you'd be able to use. Telia had some setup here, so customers can go into
our 5G lab.
Yeah.
Mm.
So how do you reach out for this? Who do we contact
to try it?
This? Yeah.
Are you a customer? Are you a customer?
Yes.
Ah, okay. Yeah, we can. You can contact me. It's not like you can't come tomorrow, but we can absolutely look at what the need is and.
Okay, great. Thanks.
Great. Any other questions? No. I have a quick question. Like for the mobile solution for the defense, what would be the coverage area which they could expect?
So the frequencies that they were using is 3.3 and 4.8, I think, and a couple of kilometers is possible depending on obstacles on the road. So if there's no obstacles, then yeah, a couple of meters.
Okay. All right. If there's no more questions, thank you. Yes, thank you very much. I'm done. We are going forward to Niels Reier.
Yeah, thank you.
Yes, from Fusix Networks. Niels is the owner and CTO of Fusix Networks, Dutch data center network provider with 26 POPs in the Netherlands and so far 0 in Norway. Yes, he's also the chairman of the Route Server Support Foundation, or SSF, and as well as the vice chairman of Nonog in the Netherlands. While he tried to sell internet to offices with Fusix since 1997, his serious career started in 1999 as a sysadmin at Demon Internet in the UK with a branch in Netherlands. And he worked for our companies in various roles before rebooting Fusix in 2013 as a network provider, network consultant, and reseller of Juniper and Nokia. So he's here with the Fusix CEO, Julia, and as a result of a long-standing invitation from Eirik Blix. So yeah, take it over.
All right, let's go to slide number 1. I think this is the first time this year I'm using a Windows system. All right, there we go. Yeah, well, thanks for having me. That was a great introduction. Just to be sure, Fusix is my day job. The 2 foundations that I will present about today are my spare time hobbies. Of course, our network at Fusix is totally automated, so I have plenty of time for these hobbies. It's no issue at all. In the old days, I was young and naive. These days, I'm still naive when it comes to the development of open source software. Because I thought that those people making that brilliant software that we all use and love are doing that in their attics on their free Sunday nights without any guidance of anyone, and this is how we got to use what they make. It is not that long ago that I realized that that is not actually always the case. That there are lots of uses for open source software in commercial companies, and those commercial companies actually get to decide what gets to develop and actually pay for it. For me, this was an eye-opener. It could be that for you everything is no news here, but to me this was an eye-opener. So how does this work? We started a route server support foundation, the route server support foundation, with a thought of having a second implementation of some routing daemon that could be used on internet exchanges. And I try to say route server the American way because I want to make sure that we don't get confused with root server in DNS, which is something else entirely. When I say we, this is the team. Well, that's a lot younger picture of myself up there. There's also Job Snijders, whom some of you may know. Our treasurer is Jean-Michel, and then we have the developers Claudio, Theo, and the project lead Bram. What are we doing? As I said, our goal is to provide a second implementation of a route server that could be used on internet exchanges. And we do that because every internet exchange is basically using the same route server software, which is Bird. There is nothing wrong with Bird. It is fine software, it works well, and it is nicely integrated in IXP Manager, and it's good. However, if the whole internet depends on just this single software package, we may have an issue. If there is something like a BGP update of death or something, I don't know, it could be anything, but there could be something that would crash Bird on a worldwide scale. It's not that I want this to happen. I love Bird, I use it myself, it's fine, but we need a second software train to run on IXPs and make sure that whatever happens to Bird does not happen to the other daemon. This is what started the Route Server Foundation. For me, and Job is actually the one who came up with the idea of having this foundation. And when he presented it to me, he pitched it to me, I thought this is a nice way for myself to do something back to the open source community, because I suck at writing code. I may know one or two things about BGP, may have written a book about it, but whatever. It's not up to me to code a new BGP daemon, however much I know about BGP itself. So, but I do have lots of experience being in boards and doing more work, getting people together, raising money actually. So that is why I told Job, yes, I will join you in this quest and I will be the chairman and we will make this thing work together. Well, that is the modest personal goal that I mentioned on the bottom of that slide. We could not start without our biggest sponsors, and there they are in no particular order. Let me start on the bottom this time, NetNod. M6, obviously, DKIX and Lynx, they are the founding sponsors of this idea. Actually, I think it was on a RIPE meeting where the whole idea came together, and those are the 4 big IXPs that said, yes, we want this. They have also substantially contributed to the bank account of the foundation, which makes it possible to actually employ developers. We employ them to write code for OpenBGPD. And that's absolutely fantastic. We also thought about, is OpenBGPD the best to start with? Well, we think it is, because it is an implementation of a BGP daemon that already has all the knobs and whistles that you may need. One of the most important things there is to increase the scaling. We want it to scale to thousands of peers without a hiccup. And that is something that people like Mate will need in the end. I will have, in the Nonog presentation, I will have an example of how far we already went. But I can say we're on track with this. And not just with developing the scalability of OpenBGPD, but there's also quite a number of features that went into already. So just to be sure, we have it is really formalized. So we went to, I don't know, a notary office. You probably know the thing. And he wrote down that now we have a foundation and this is the board and everything. So it's all official. And we, as the executive board, are being overlooked by people like Mate, who oversee that the development is going well. He's in the supervisory board. And then the technical guys from NetNod, M6, Lynx, DKIX will work with our project lead and the developers to make sure that everything that is developed actually goes towards creating a better BGP daemon. What we have done so far since the start of the foundation in 2020 is more than can fit on one slide, so you get 2. And it includes everything here. One thing that was very important for the exchanges was to have support for Alice Looking Glass, because every exchange seems to use that. So that is now in there, although I think with 1 or 2 bugs, but we are talking to Thomas King about that from DKIX. Is there anything else that I need to specifically say about this slide? No, I don't think so. I think Florian already provided some technical detail for this meeting, right? So I don't have to go into it a bit more. We are also going to implement new stuff. And oh, I see that ASPA is on the future Outlook slide. It should actually be on the previous slide, because that is now fully implemented in OpenBGPD. ASPA is an extension where you basically define what kind of, so what the peering relation actually is. So one side will say, I am a transit provider, and the other side will say, I am a customer. And if those two don't line up, if they shouldn't belong together, then the session will not come up. And in OpenBGPD, we now have a working working solution for that. So other vendors can start implementing this as well, and say that and test against that. So that looks great. We also want to improve the support for the Linux kernel, because the programming of all the roots in the routing table is a little slow on the Linux kernel, but we need to get that done and make sure that it goes quicker than that. A major job for myself is to make sure that we have enough money to sustain the foundation, and that is actually my primary input for this. We know that many IXPs are using IXP Manager, and that is absolutely fine. We also know that it comes standard with Bird, and that if you set up your route servers using IXP Manager, you will have Bird in the background, which is also fine. We are trying to work with the IXP Manager people to get them to have the secondary root server be OpenBGPD. So even if you run a smaller exchange, there may be an upgrade to IXP Manager at some point, where you may have a route server that works with OpenBGPD. So I just wanted to say, even though it is my job to raise money for the foundation, it's not like you have to give us money in order to be able to use the product, because the product is really the standard OpenBGPD that everybody gets with OpenBSD distributions, or even you can install it from Linux these days. It's very simple, and everybody gets that. So there is no fork or anything. There's no secret code. Everybody can use it, and that's absolutely fine. And I hope that at some point it will be implemented in IXP Manager, and even more people will start to use it. That is actually my update about the Route Server Foundation. Are there any questions about the Route Server Support Foundation? Ooh, none. Then I change hats. I won't change clothing, don't worry, because this is already the official NL-Nog hoodie. So it has the NL-Nog logo inside. Sorry for the people on the stream for the noise on the microphone, undoubtedly. Because, I am also the vice president of NL-Nog. And I'm here to say one or two words about what NL-Nog is doing, so the Netherlands Network Operators Group, and why we are doing it. And I'm not saying anything about, I'm not saying this because I think Nonog should also be doing this. I'm just saying what we are doing. And if you like our goodie bags, then I would urge you to talk to Marius and Erik, but you want goodie bags as well. Hang on. For the rest, it's all fine. How did this start? No, I don't want to take too much credit, but it was actually me again. It used to be when I worked at Demon Internet, everybody in systems administration and network administration had to subscribe to Nonog, which we obviously all know. And that was kind of the de facto platform mailing list where you would exchange things about networks and everything. And I've been on that list since 1997, and it was all fine. But I was sitting there with a colleague of mine, and we were like, yeah, what if there was also an NL-Nog? How would we do that? And basically that was actually started in November 2002 by setting up a mailing list that M6 was kind enough to run on their hardware for us, and basically they sponsored that mailing list until a few years ago. And so that's why the first email to the list is actually from Steven Bakker, who still works at M6 and will say a few words about the start of NL-Nog on our upcoming NL-Nog Day, which is next week. The mailing list is, as you probably can imagine, not as active anymore as it used to be. There are other platforms that people tend to prefer over email, but it is still there. It still works. I will get back to what else we do. However, when I was sitting there with my colleague Marco Hogewoning, he also used to work at the RIPE NCC, is now moved on, and we started that mailing list. we did not think about what the future was going to be. And well, we have Job again, Job Snijders again, who started getting involved with doing things for Nonog. And he found that there were companies that wanted to give us money and that wanted to give us servers to run services on and co-location for those servers. And that technically, since it was all given to him, he would have to enter it all on his tax form. And our national hobby is not to pay tax. So we had to find a way to do this differently. And the way was that Job came up with the idea to make this a formalized foundation. And this actually precedes the Route Server Foundation, right? So it's two totally separate things, just to be sure. So there we were at a notary office again in 2014, yeah, November 2014, setting up Nonog. And this is the first page of the official statement that we are now a foundation. There were 5 board members at the time. Job has since focused on the Route Server Foundation. I'm still there, Nathalie is still there, Thomas is still there as a treasurer. Sander is also doing something else by now. And we have 2 other board members, Teun and another Niels, that makes meetings very easy. And we're all in it to get everything done for Nonog. So it's 6 board members, and it is a formal foundation. So our sponsors were now able to get us actual money or hardware or whatever, and we actually write contracts with the sponsors. So there is paperwork if somebody wants to sponsor Nonog. Now, there doesn't have to be paperwork, but there could be. So if you have a large, entity sponsors us, for instance, well, you can imagine that they cannot send money without paperwork. So that's why we have to have the paperwork. It also has a disadvantage that I will get back to later on. So we have a contract that describes that sponsors will give us money, and in exchange we will organize 3 events where we will mention the sponsor names and put them on the t-shirts, the free t-shirts that everybody gets afterwards. And we also pay for the food and drinks with the sponsor money, of course. One other thing that we do with that sponsor money, and that is also significant, is to put it towards software development once again. And I will get, in the next slide, I will show you what the software development is. And obviously, it was very tempting to just plug all the Nonog sponsors again in this slide, but I didn't do so. I think maybe the Nonog sponsors might not appreciate that. So if you want to know who the sponsors are, next week, Nonog Day, it will be fine. This slide describes what it is that we all do in Nonog. Now, that mailing list is still there, the mailman mailing list. I don't think it's upgraded or anything. It's just still there and still working. It's wonderful. There is also an IRC channel. Yes, people still use that. It still exists. There's also an issue with that, though. It is a very active IRC channel. It is really thousands of lines per day with people, and it is absolutely helpful to know, like, when somebody loses a dark fiber going into Equinix AM3, did anybody else lose something there? And then when you have yes or no, but you know where you need to go and search. So I personally think, I don't know of a different industry where competitors would communicate that directly with each other and help each other keep each other's services up and running. I think it is very special. It happens every day. And then we have a couple of websites that help for people who are doing routing. There is the Nonog BGP filter guide. It's being updated all the time when new things come out. So that contains hints on how to configure your import and export policies on your routers to make sure that you, don't accept any bogon prefixes, or that you don't accept any AS paths that are extremely long, that sort of thing. The website is there, and if you have any updates for it, it is, I believe it is administered through GitHub, so you can change it yourself, actually. Then there is the Nonog ring, and many people will probably know it already, or maybe even participate, but if you don't, then please have a look at their website, ring.nlnog.net. This is another invention of Job, and it is actually a very simple idea. You provide a server, could be a virtual server, and you get access in exchange to all other people's servers. So you can use that for troubleshooting. So if you have, let's say, an issue, and yeah, I see all my traffic via, I don't know, PCCW is not working. So you log into PCCW's ring node, and you make a trace route from their network to yours. And you get that access, you get troubleshooting tools. There are tools to do pings, for instance, from all servers, or from a set of servers, or from a random set of servers, so you can see if everything still works. And that will give output like, so you can ping, for instance, an IP address on the ring. And then you get output like 63 servers respond, it's online, and 23 respond, it's not. So you know that there is an issue. And the only thing you have to do for this is supply a machine, a virtual machine, or physical machine, whatever you like, and some SSH keys, and the keys get distributed to the other ring nodes, so you can log in to everybody else's machine. And yeah, well, you're in the ring. I see people thinking, oh, this is a great way to do DDoS stuff. We do tell people that it might be wise to rate limit the port of the virtual machine or the physical machine. And yes, we have had 1 or 2 abuse issues, but the ring admins are really very quick in getting those resolved. Then there is the Nonog looking glass. Well, this is a looking glass, as you know and love it. I've put a screenshot there of the status of how it was on Monday, and of course everything is too small to read on the bottom. But on the bottom it says, I can't read it either, not even on this screen. But there's more than 100 peers, and there's over 80 million roots in that root server. We have recently changed out I said root server a couple of times. We have recently changed out the route server software for OpenBGPD. I don't know why. This is something that will keep growing and growing, because we expect to have about 250 peers, and we hope to reach about 200 million routes on this instance. If you look at the looking glass, well, you can just enter, well, you know what the looking glass is. You can just enter your IP address or AS number or anything and just look it up and see how it is routed in other people's networks. The final tool is IRR Explorer. That is another invention of Job. You can reach it on irrexplorer.nlnog.net. Put in your IP address, put in your AS number, and you see everything that there is to know about that resource in the IRR databases. So the RIPE database, Erin database, even the thing from Merit, RADB. It's all analyzed, and it gives you a list even of recommendations of what you should do. So I wanted to put a screenshot there of some of the Vue6 IP space, but I saw that there was one that had no RPKI ROA, so I didn't want to include it because, yeah, I did not write that day one book about implementing RPKI for nothing. So if I would show you how we haven't done it properly, then don't tell anyone, right? And then, of course, as the most major activity of NLNOG, there are the events. Now, there we go. This is a list of the events we had so far. The first one was in 2014, and that was actually in an office, and it was on a Saturday because we wanted to try it out, and we didn't know if people were going to get a day off for this or that their boss would allow them to go or whatever. So the 2014 Nonog Day was on a Saturday. And the turnout was about 50 people, and it was really nice. It was a nice office where everything was. It was the presentations were great, and everybody said this feels like more. From the start, even that very first Nonog Day in 2014, it was already streamed live, and the recordings are still on YouTube of that 2014 Nonog Day. All of them since then, the big Nonog Days have been streamed live with recordings saved on YouTube. But we, there were many other events because we promised our sponsors to organize 3 events per year. So there's always a New Year's drink. Then we hire a bar somewhere, and people come and drink beer on the tap of the sponsors. And that's in the beginning of the year, obviously. And then there is some event before the summer holiday, and then the big Nonog Day after the summer holiday. The before summer events are a little experimental, so we've had one that was basically a barbecue with some presentations. We also had a campsite event, and that was pretty funny because it turned out that one of the sponsors could arrange for a dark fiber from the campsite to a near data center. So people had 10 gig in their tent. It was pretty funny. We also had an expert sessions barbecue, and the expert sessions thing, to be honest, it was not that much of a success, but maybe you can take it and do something with it. People could make an appointment with an expert in something. So an expert in RPKI deployment, an expert in IP address registration, that sort of thing. Make an appointment and then just have basically half an hour of free consultancy about the subject. It was not that much of a success. Fortunately, the barbecue afterwards was. Nonog Cheese Exchange, that was a nice one. That happened by surprise on a RIPE meeting in Rotterdam, and I think 1 or 2 people here were actually there. People took some cheese from their hometown, and we put everything on the table, and there was some wine, and everything was fine. That was the Nonog Cheese Exchange. You can imagine that in 2020 we started to have a bit of a problem because there was this thing going on and we could not get everybody together for a meeting, but still we had our sponsors who demanded 3 events per year. So the Nonog Day, well actually the pre-summer event and the Nonog Day in 2020 were done all remotely. So on the Nonog Day in 2020, after the summer holiday, I was the host, like Marius is here today. And this was my, my workplace as the host. It was, my office with a laptop and a microphone for hosting the whole show, and the laptop for monitoring the IRC. And that's it. The whole thing went to actual TV studio. All the presenters were streamed in, and everything was mixed in one stream, one television program. And it actually worked out really well. The Nonog Day in 2020 was also done in this way, and it also worked out really, really well. I must say, though, that if you have an event where everybody presents remotely, it is easy. If you have an event where everybody presents locally, it's also easy. But if you have an event where you have both, it's really hard. The last event, and I'm sure the audiovisual guy in the back can confirm, the last event we found out a few minutes before a remote presenter would start that we had no audio to feed back to him. So he could not hear us. So the question session was completely cancelled because it made no sense. The guy could not hear us anyway. So that was really, really hard. This time, the meeting next week is going to be with 2 pre-recorded videos actually, because then we know it works and we have the presentation working and everything is fine. There's also another anecdote, and I'm happy that Nonog did not fall for this same thing. We had a presentation last year, which was a nice presentation about our COVID app. And the app was made by a certain department, certain ministry, and somebody from the ministry was presenting. And his presentation contained a photo of some ministers meeting to talk about the COVID app. And that photo was made by the governmental press agency. And his presentation contained the photo. We got a letter from the governmental press agency asking if we had any right to use that photo. Because they thought we didn't. So we ended up paying to get rid of it. And the guy in the ministry we never heard of again. But this was pretty funny because maybe I see it as an additional tax, I guess, right? Because one government department making us send money to a different government department, it felt a bit wrong. And I was happy to see in Marius's mail earlier this week that all presenters are urged to make sure that they are not putting any copyrighted material in their presentations. Otherwise, I would have given you the hint. Not that I think that the Norwegian government would ever do something like this, of course. Next week, we have our 20th anniversary Nonog Day, and it's no exaggeration because we started in 2002, remember? It will be in the same venue that we've held it for the last couple of years, called Podium Mosaic. This is it's a bit like a church with a podium. It has capacity for about 350 people, but we limit it to 250. And again, it will be streamed live, of course, all day. It will be on YouTube. It's going to be a wonderful program. I will show you the program next. We also have these vests made with the Nonog logo that you can purchase. They're not free of charge. You will get the t-shirt though, and you will, of course, get the goodie bag. And I know that you can all keep a secret. So nobody in the Netherlands has seen it yet, but you will. This is the goodie bag. Isn't it nice? It has our logo on it. And you can open it up. And it has space inside for a MacBook. I don't think Windows will fit. And it's going to be full of goodies with sponsor logos on them. But this is the bag. And you will get it if you're there next week in Amsterdam on the 30th physically. It will also have the free t-shirt in it. And you can buy the hoodie if you want, or the vest. But keep it a secret, because nobody has seen it yet in the Netherlands, right? This is totally new. About the program, this is it. This is what we're going to do. We like talks, of course we like technical talks. So there is going to be one by a guy who is making his own intent-based networking setup at home, actually. That's technical. But we also like talks that are a bit more social. So we've had talks about women in IT. We've had talks about how to assess if you are still in the correct job. And we find that those talks are the most are the best received talks of all. Well, there is one that is actually had better reception. That is the one from Jared, who was presenting about how he put fiber in his small municipality somewhere in America with a few hundred people living there, and his investment to get fiber to that town has really changed the whole town. And it is still on YouTube, and it still gets lots of views, more views than I myself get, because my son found me on YouTube once, and he said, "Daddy, I don't think you will get a lot of views with this." So anyway, there will also be a talk about how to find young talent, because every time we have an NL Day, that's every year, we see the same people, and everybody has become 2 years older. We are asking everyone to bring a younger colleague to NL and make sure that they also get imported in this network world. The NL Day typically ends with a quiz, and the quiz is Kahoot. It's general knowledge, so we have 250 people punching their phones. It's not about the content of the NL Day itself, so you can participate. The only thing is that if you want to be able to win a prize, you have to be there physically as well. So if I were you, I'd start booking. The quiz had a prize that is, by today's standards, unimaginable. In the beginning years, we had a sponsor who would give away a provider independent /24. For some reason, this doesn't work anymore these days. There will be different prizes though, and they will be worthwhile. So this is next week. Be sure to tune in on YouTube if you can't make it physically, but if you can, then make sure you get there, because you get the goodie bag and a t-shirt and everything. And I would like to ask if you have any questions about NL, something that we could do better, something about our tools. Should we develop something new? Should Nonog adapt things that we do, or should we adapt things from Nonog? I don't know. It's been fun to be here anyway, and I would like to hear.
I once, a couple of years ago, asked about the Nonog ring for FreeBSD.
Yeah.
And at that time, the answer was negative.
This is, I thank you for your question. So the question is the NL ring node running on a FreeBSD host. I don't think there has been any progress made in that, although I love the fact that you want to use FreeBSD, because my relationship to Linux is not similar to my relationship with Windows, but I must say I prefer the BSDs myself. But the fact of the matter is that the whole ring system, it's hundreds of nodes by now, and it is, again, highly automated. So it needs Ansible and a certain Linux version to be able to put all the files in all the correct spots, I'm afraid. I will take it up though and see if there is maybe something that can be done, because I also love FreeBSD. Thank you. Any other questions?
It's not really a question, but I would just like to say to everybody in the room who's not on the NL ring, please join. Because it's a fantastic debugging tool. If you get a report like, oh, there's some user in Portugal that has problem accessing your services, you can just most likely log into multiple hosts there and check connectivity yourself. You don't have to ask the user to come up with a trace route for you or something like that. And for the price of having a minimum spec VM, it's an absolute bargain. So if you're not already on it, please join.
Thank you. All right. Well, if you have any other stuff, I will be here for the rest of the day. So you can find me. Thank you.
Thank you very much.
Yes, thank you very much. Yes. Next in the program, we have a coffee break, which will also be slightly longer, but not by much. Please enjoy, and please be back here on time. Thank you.
Hello? It's me again. During the tea break from questions, I realized that I forgot to mention two important things about NLNOG. First, NLNOG Day next week. If you decide to show up there, please book a ticket in advance on nlnog.net. Don't just show up, because there might not be place for you. Second, the language on NLNOG Day is English, so that will be fine for most of you, or all of you. The language before the summer event, so the before summer event is Dutch. So if you want to join that next year, then you may want to take up a course first. And the language on the drinks in January is, well, whatever language there still is after a few beers, right? So that's important. Thanks.
Yes, thank you. Yes, very well. We have a couple of more points in the agenda before the dinner. So next up is Red Pill Linpro with their public cloud implementation. Trygve Vea will present. He's an OpenStack solution manager at Red Pill Linpro. He's a full-time system administrator with a passion for technology, and he's enjoying exploring new tech and spends significant amount of time prototyping applications, games, monitoring services, and the like. So yes, please.
Hi everyone. My name is Trygve, and I'm here to talk about our cloud, or the our Nordic. First, let's talk about Red Pill. We are a almost 40-year-old company that has been in the open source business since the beginning. In 2021, our revenue was about 500 million kroner, almost 300 employees, and we are expanding, of which 100 is located in Oslo. We have 350 customers, give or take. Our office is down at Rebel in Universitetsgata 2. It's a short walk from the Nationaltheatret subway. In Red Pill Linpro, there is a department called Cloud Ops, which is where I work. I work there together with 35 other people, and we do system administration using DevOps methodology on our cloud and on third-party clouds and on wherever our customers decide to have their servers. Our primary third-party public cloud is of choice is AWS. We are AWS partners, but I am here to talk about our cloud. We run our infrastructure across 4 different data centers in Oslo. Digiplex and Hans Møller Gassmannsvei 9 is familiar to network people, I believe. We also have some equipment in Sandakerveien 121, the former printing press of Schibsted, and Østre Akervei 68, just down the road from Hans Møller Gassmannsvei. These locations are connected with black fibers. So we have a fiber mesh between these 4 locations, delivered by Hafslund as of recent. Our cloud guarantees that storage is happening on Norwegian soil. Our employees do system administration within the EU or the EU economic area, and our owners are Swedish. So we do not have American overlords pulling the strings. And to deliver
deliver services efficiently from our 4 data centers, we have built our own cloud based on OpenStack, which is a series of open source projects. It's been around for more than 10 years now. We deliver virtual servers that covers a pretty broad range of from tiny burstable instances to pretty big dedicated instances. We offer storage and some managed services directly from our cloud. And when we're talking about GDPR and Shrimps, it's natural to start with the storage part. So our 3 tiers of storage that we're offering in our cloud is within these 4 locations. We have 2 Ceph clusters that are triple site replicating all the data that you store in them. So they are, if one data center is completely gone, all the data will remain available and redundant in 2 other locations. This happens on a block level, and this can happen on an object store level. We have a S3 compatible API that is also available from these 3 locations. When an external storage solution isn't a good fit, for example, if you like to build distributed solutions, we also offer local block devices on the hypervisor itself that will be stored on a RAID 1 on NVMe devices. So this reduces latency as much as possible and is very suitable if you have solutions that you want to keep in separate failure domains, so that an outage will affect you as little as possible. And most clouds offer some kind of compute service. Usually that's virtual servers. And I'm gonna talk a little bit about our approach to this problem. So every now and again, a new chipset is released. This every second year or so. The big vendors, Intel, AMD, and sometimes other release new chipsets. Memory speeds are increased. The PCI buses get faster. And if it's a good fit for us, we look at what's available. We specify new hardware that we can deliver services on, and we try to tune it just right so that we get the most amount of performance for every buck. This is the lowest amount of cost for us, means that we can actually compete on the prices that of the products that we end up selling. And when we find a spec that fits, we stick with that until the next generation. So when you buy hardware of a specified SKU, you know what you get, because you will get the same again and again and again. It's not like we will, within a server generation, change things up. Consistency in experienced performance is important for us. And this is what we're currently running our servers on. We have found that these the AMD EPIC, the latest CPUs, are blazingly fast, and that model is just right at the best bang for the buck. And the local SSDs are blazingly fast. Now, to understand how how we've designed our clouds and what products we offer, we need to look a little bit about what our customers run. Red Pill Pro has a lot of customers in media, and very common kinds of software that we run on our customers. We have a HTTP cache. Varnish is usually the first thing your web browser will talk to when you visit a large Norwegian newspaper or media site today. And to scale Varnish, you need a lot of memory, and to scale throughput, you need a lot of CPU, especially since everyone started to encrypt things. CPU became very important. Kubernetes has become very popular as of the last decade almost. Servers running Kubernetes will often become tightly packed with applications, and they will use the resources that they get. They will demand low latency and high throughput from the hypervisors as well. MariaDB is a MySQL compatible database for the most part. And Galera is a clustering technology that a lot of our customers use that lets you set up your database cluster in a 3-node active cluster. So what you can do in our cloud is that you can order a database cluster that is triple site replicated, announcing a service IP through BGP, either failover or active, from 3 different locations in Norway. On local SSDs for low latency and high throughput. Our CPU flavors comes in 4 different groups of capacity. No, 5 different groups of capacity. Either if you want some medium amounts of memory, high amounts of memory, with SSD or without local SSD. If you don't have local SSD, you will need to store in an external storage solution. Each of these groups have 5 SKUs. I don't want to bore people with tables. What I want to communicate out to you is that we have offerings in varied amounts of specifications, service specs. In addition to these, if starting with dedicated capacity is too fancy, if you have lower requirements, or maybe burstable instances is for you, we have that too. In what we do with burstable instances is very similar to how AWS have solved this problem. Because in the early days of virtualizations, people would just pack their load on a hypervisor and just see how things goes and see when things starts to break. But in a multi-tenant cloud, having consistent performance is key. So what we do is ensure that instances that have sustained load over a certain level need to upgrade to the dedicated capacity. And if you don't have sustained load, then you will be fine with these instances, and you will never overload the hypervisor to a point where you affect other customers. And the flip side of that coin is that no other customers will have so much load on that server that they will affect you. The problems that solves for us is, for example, that we don't need to spend our time deciding oh no, these two customers, they use so much resources that we can't run them on the same hardware, for instance, which is a boring problem. We do have older generation SKUs available as well, but we're mostly sold out. If our predefined set of SKUs aren't a good fit for you, then we do something that I believe is quite unique. We allow our customers to specify their service for themselves. They can buy their own hardware using their own ways of hardware procurement, or they can ask us to buy something according to their spec and get things just right for them. Using this approach, we will assimilate their hardware into our OpenStack installation and give the customer dedicated access to this running load on their own servers. They can then grow, expand out and use other features of our cloud, for example, using managed service on their own, by us on their hardware. They don't want to do database administration, for example. And if their servers go full, they can use our server capacity and expand their about 50% of our hypervisor farm is using this model. Network-wise, you can define your own network architecture using overlay networks. Our OpenStack cloud uses VXLAN for the most part under the hood. We also use VLANs on layer 2 for if you need BGP functionality or things like that. OpenStack provides a API for handling firewalls. In addition, since we are a relatively small and flexible actor, it is possible to contact us and ask for a private interconnect on either layer 2 or layer 3, for example, using provider net directly attached to your interconnect, or BGP over a private VRF, for example. If you want to know more about this, Tore is the guy to talk to. He can go into the specifics. We have some managed services as well, and these are basically key turn solutions that we can set up in minutes using the building blocks specified earlier in the presentations. Like, you can have a big instance using local SSDs, triple site replicated across 3 different data centers, using a database engine of your choice. It will get monitored and alerted to our on-call personnel in minutes, and backed up to our object storage. This API is used to automate the building of test environments for some of our customers, where they have every night we do database dumps, and after these database dumps are done, the customer recreates their test environments to have production-like data in their software test stack, which is really nice. OpenSearch 2 is our Elasticsearch option. Elasticsearch changed their licensing terms, making it increasingly difficult to provide as a service offerings. But we have OpenSearch now, which is a fork from AWS, I believe. We also offer something called OpenShift, which is a container platform, which is, if you don't want to deal with servers directly, you can just deploy containers on a OpenShift installation, which is highly redundant and based on Kubernetes. This is based on the open source edition of OpenShift. OpenShift Kubernetes distribution, it's called. And we also do traditional server ops. We haven't forgotten how to do things the old school way, even though we try to be with the times and do everything through pipelines and the likes. That's what I had, really. So if anyone has any questions about our offering or about OpenStack in general, about Red Pill in Pro, now is the time.
Yes, no?
Not everyone at once.
No. All right, I guess thank you very much. Thank you, Ture. I will introduce the last slot now.
Trygg der.
Yes. Og det. Yes. We are getting close to the end of our program. This is the last presentation for today. Loretta Raulike from Global Connect, where she works as a senior manager solution engineer. She will talk about SDX solution engineering. Loretta, she has been working in the telco industry for 15 years, and she has wide experience in leading operations, development, and engineering teams. And she will talk about software-defined networking solutions, solution engineering, and how we create value for the customers using SDN. So yeah, here's the presentation. Yeah, I think you can take this one, and then your slides should be here. Nice.
All right, good afternoon. I have an honor to take the last presentation of the day and hope you will find it interesting. I need to remember to stand here that streaming works. So I'd like to take a chance to speak a bit more about software-defined world and also taking the Global Connect experience where I joined 3 years ago, where we started to build basically software-defined WAN. So the initial topic on my presentation was SD-WAN solution engineering, but while preparing, I kind of updated to SDX, or we call it SD whatever. So that is also including LAN and Wi-Fi, and also security becomes into the picture, and yeah, different Gartner and other trending kind of investigators looking to a term called SASE. So I'd like to spend the last presentation or the time slot for today speaking a bit more on my experiences in Global Connect and how did we build and explore basically the software-defined world experience. So the agenda for today, I will focus of course on technical stuff, but also wanted to take a chance to speak a bit more how do we map technical functionality and possibilities towards the actual customer needs and connecting what are the customers' needs, why do they need it, and also how do we create value based on technology and technical stuff. Solution engineering is also the space where I really find technical things like me and solution engineers in the team. We are really driven by technology and the drive there. But at the same time, we also have a big part of understanding the customer and making the right solution for them, not coming, just something from the shelf and saying that this is the coolest thing that you can get, but more understanding that, nothing fits or no size fits all, and that's also make interesting to work in the solution side because we have plenty unique solutions. And I will also talk about 3 different customer cases as an example, identifying also what technical challenges and what customer requirements we had. And I have an example of a retail sector customer, and then also financial sector, and one like big international customer as a kind of example there. So I will start with a bit more like customer voice, and this is a bit more like where have we started to look that software-defined networking might be a solution to some trends rather caused by issues on some existing or old solutions experienced by the customers, or being something that they lack or would like to have as a new functionality. So rather, fixing something that is not working, lacking overview, being a kind of quality stability issues driven, or needing something new. And we had also the nice presentation on the cloud part, and it's definitely trends, customer moving to cloud and things like that, that also kind of impacting the environment around and so on. So Global Connect being, like a traditionally fiber company, we have definitely the largest footprint of hundreds of or 100,000 kind of kilometers of fiber. But at the same time, we were looking to, if we come to the customer and say, would you like 1 gigabit fiber to solve, your issue on issues that you have difficulty to discover, that wouldn't be, like a good match. So that's why we kind of looked, how do we address different customer challenges, needs, requests, and how do we map it then to the right functionality or technical stuff. So that's why I would like to spend just a few minutes on showing, what I just mentioned, the customer need, why do they need it, and then also how do we realize it. And the customer need most likely will not come asking that, could you kind of, give me the specific feature. They would most likely ask that they want to have something more, humanly understandable. So I took just this example as one retail kind of customer. For example, they would like to have streaming music in the stores, enabling their kind of clients to use the app to rather purchase or navigate in the store. Definitely being online or always available, that is not anymore the unique requirement, that is a must, I would say. And different kind of workplace or remote workplace that increased during the pandemic times, but that's also a flexibility option these days as well. And new locations opening, moving, a bit more connected to the remote side, but at the same time, being a bit more on that side. And the question about why is also not just because we want it, it's also behind every business, if it's a private kind of sector, would like to grow, increase the sales, increase the customer experience, enable a good workplace to their employees and things like that. That also kind of makes a lot of sense there. And then finally, we come up a bit to the how part. And many of the functionality that is listed there in my list as an example, it's not really, that's something that was created with SD-WAN or SD kind of technology. It's been already existing in the market before. For example, firewall stuff, it's been ages when you had stateful firewall. Of course, next-gen firewall came out into the picture, but many vendors, many players kind of giving you that side. So that wasn't really unique, but more what was what was possible with software-defined stuff is that it's much easier to combine different features or functions when it's software, which you can build it on standard kind of hardware and also avoid many boxes doing this kind of stuff on the dedicated hardware. So that made the chance that we can provide much wider package or functionality in overall, and addressing different customer needs and making it simple to operate, simple to understand, and of course pricing never been the smallest topic in the end. So in solution engineering, we definitely look to customer needs, trying to understand their why. And our strong part was also, or still is, that we have a solution engineering department, which I'm leading, and then having 20 engineers across the Nordics. And we specifically look to understand and make a good design, because I truly believe that good design makes it easy to deliver and makes it easy to operate for like our managed services part, and that also makes a value to the customer. So spending more time in really understanding the customer needs, also giving them like our best practice advice. So it means that of course we have multiple functionality options, but this is what we kind of recommend, and also telling why. So what, why, and how, that's kind of becoming of our DNA. And at the same time, really connecting to the technical part of it. So the challenges that we address is, of course, not new, connected, to complexity, monitoring or visibility challenges, still wanting to be stable, but at the same time flexible, compared with the change and then move and so on. And not the last, as I mentioned, kind of cloud strategy, which is helping to get going from the old WAN solutions towards something more future-proof and scalable and flexible and whatever kind of word you can get there. I'd like to spend just a few kind of key things on the technical part. What are the benefits or what are we working in Global Connect on the SDX functions? And again, if you start, for example, with application performance or redundancy or local internet breakout, these are the functions that are, I believe, known to many of people, and they are not, again, unique in doing something new or something really cool. But at the same time, we have a combination, for example, and migrating the legacy customer to a new WAN solution, we have a functionality which we call it service gateways, like interconnecting the old MPLS and IPVPN network towards the, for example, internet-based IPsec on top of the SD-WAN kind of site. Guest network became also very much popular. Many companies on both private and public sector would like to enable some functionality or just access for the users, both customers or clients or visitors there. So that is also one area to look into that. Data analytics gathered as well on able to track, for example, how much time your customer has spent in the store, in which area, and how do they move, for example, between. That's also something kind of behind that the technology is enabling there. And security is becoming a fluffy word, kind of highlighted to every presentation or every talk, but that's still the world that we are living in. And firewalls and malware or whatever kind of name you can get there, that's still important conversation basically with every customer that we have, and also what our scalable and future-proof solution are based on, focus on networking and security into that side. We also have a function called reach, which is also one benefit. For example, we have a Norwegian customer that has, for example, abroad locations. It might be not so difficult to deliver in Sweden or Denmark, but if, for example, the location is really remote, I'll have an example, I think, in the use case. In Asia, let's say, or in Thailand, it's been really time-consuming and expensive to enable kind of MPLS or the connectivity to the remote sites, and many complexity and difficulties that has been raised by the customers. That's why we addressed it with more like software-defined stuff. I still couldn't resist to take my almost favorite feature to talk about today as well, which is called a bit more application QoE. And I still believe that's an example which I see in many customer cases, and why it's so easy to play with that, and also what the benefits the customers are seeing. And multiple scenarios, for example, enabling the best path selection for different applications, defining different rules, business applications versus some nice to have, especially looking to primary, backup, latency sensitive, etc. That enable also to have a really good baseline. How do we show to the customer that it's not only, let's say, 1 gig fiber that you get basically a control of the traffic on top, and that is creating the value, that you have a chance to take control of it, and at the same time to make it work according to your or kind of the customer needs into that. So I think me and my team, we also spent a lot of testing and verification and playing around. Many companies have moved definitely during pandemic to virtual meetings, different size of it. So the standard function kind of became Microsoft Teams being prioritized. That's kind of today's reality. At the same time, there can be different cases related to criticality of different functions that the customers are kind of using that. So then it comes the part that I would like to deep dive a bit more, giving you some more insights and some examples from our journey in Global Connect. And first customer case that I would like to mention is a bit more related to the retail sector. And we had a customer with hundreds of locations and shops across all the Norway, situated basically all over from south to north, and having challenges basically to IT personnel to really support that kind of stuff. So the task was basically looking to migrate to legacy WAN to more kind of flexible WAN. And the customer was looking also to move to Microsoft Azure in some of their applications. Client VPN came out also as a remote possibility for their employees to connect, and also their partners to look into that. So guest network that I mentioned is basically all the combination of things, including also the backup solution, and just they had a few international sites, not that many, but still nice to have a same kind of connectivity and being them able to access all the resources that are available for internal kind of sites. So the kind of our solution was building software-defined solution on top of that. We enabled the virtual CPE in Azure to have like a site like normal other stores from the customer point of view. It was also the improved customer experience that the traffic didn't need to go via central firewall all over, from Tromsø or whatever back to Oslo and back again and so on. So some, of course, critical applications were left to use the MPLS, but then straight user internet traffic could have been done with the DIA in each location. So that was the benefit that the customer saw. Then LAN and Wi-Fi in all branches, like we use it as a managed services, much easier to monitor and see, plan the coverage, making sure that both Wi-Fi and LAN is suitable to the customer need. And mobile failover, currently on 4G, but looking forward to 5G. That was also the presentation earlier today. And that made basically the match, or why the customer saw the value, and which technical features did we use in order to realize a new solution. International locations, of course, there were just a few, but that the customer still saw more cost efficient, which wasn't the biggest saving, but at least still the benefit going through the overall total solution, having every site in the same portal to kind of track the availability and visibility and so on. And that was the benefit for that kind of customer side. So again, behind all that, there were reasons to have a stable connection to each store, increase the sales, make sure that the customers can explore and find different items in the stores physically, but at the same time being securing the payment functions and etc. that's been basically solved with the technical realization of the solution. Another example, which I also would like to talk a bit more, is the financial sector customer. Financial sector has been also a bit more, let's say, challenging, connected to, if I put it like that, security requirements. Yeah, every company has security focus, etc. But if I interpret it, I think finance has it a bit more strict than some other, for example. So we had a customer also that requested MPLS underlay as such, wanted kind of to have a clear separation of internal network, and compared with kind of internet access. The ambition was still kind of have full control of security and firewall stuff for themselves. So we had like integrated security solution, which means that we haven't built the next-gen firewall functions specifically on SD-WAN CPE, but we had the integrated and enabled kind of encryption service into that. And that was the benefit that also the customer saw. They were kind of complaining that had multiple vendors as well, complex setup, hard to maintain all the kind of SLAs and avoid ping pong between different vendors when they try to identify some issues. So one of the key thing that was we built one vendor and basically one provider from our side on that side, and that seems simple and not too technically challenging, but at the same time a value that you bring to the customer. So it doesn't need to be always something really cool that gives you the benefit to the customer, but also addressing the right needs. That that was the case into that. The customer also had like multiple internal and external sites, like a financial sector. They have, for example, integration to nets and different other kind of payment system providers. So that was also a need to have a proper connectivity and at the same time clear design on that. And of course, the SLA demands on jitter and packet loss, that was a bit more connected to our underlay infrastructure as well, that we combine it with our fiber footprint and services and made sure that the customer gets the best possible routing as well via the network, avoiding high latency or jitter on that side. So that was also one of the things. And then the last example, which I had also the more international customer. We still have like it's Norwegian customer, but being spread all over the world with different locations, also trying to expand their business worldwide and looking for also the connectivity solution that would enable them to do. So it's been like a transport company. And of course, they kind of drive all over the Europe and also even to other continents and opening up new locations, have some temporary kind of places, etc. So that also made a need for them to have like a flexible WAN solution into that. So they still kind of also wanted a bit to have like a graduate migration, having the Global Connect MPLS in Norway, and then using internet and IPsec basically on top in the foreign locations based on that. They also had an ambition to have like logistic systems in the public cloud, which was also kind of a good combination with what we can do with our SDX functions. So the virtual CPE in AWS, that was also like a part of the customer solution. And we also had like service gateways to interconnect MPLS with internet and also enable internet access to these locations that were requested, and then letting also the customer to use the reach product in the locations that Global Connect didn't have, let's say, a footprint in all over the world on that side. Next-gen firewall also made, again, the benefit that each location could be then protected kind of locally, both on malware and DDoS and things like that. So that also made the customer to choose and being able to address their needs into that kind of site. So that's a bit more on the different use cases and different customer examples that I wanted to choose a bit on that. Last maybe thing or last slide that I had also to bit where do we have focus right now? Of course, it's been a journey going with SD-WAN and SD-LAN and Wi-Fi and so on. So it's still like full network as a service functions, improving, developing, scaling, and enabling new functionality and so on. At the same time, security as a service, including, again, existing stuff on anti-DDoS, the next-gen firewall, VPN, and whatever that will kind of come. So that's basically the core what we see in Global Connect, and also in the solution engineering into that side. Last thing is also very much important where we as a company is focusing, and that was also mentioned in the several presentations today, like user portals and self-service and easy and interactive, easy to understand, easy to kind of do stuff and find out. So basically the portal functionality is also based on the APIs, what we are developing and building in Global Connect. And that is also creating value to the user. The current kind of SD-WAN functions, we also have like a portal deep diving a bit more like into the deep technical details, but also mapping and connecting the different visualization to any kind of user, which could be technical or non-technical. That's also what we work jointly in Global Connect, looking into that. So I haven't specified any specific the kind of design of SD-WAN, etc. I think that's quite known and things like that, and haven't mentioned any specific vendors or names. But just to mention that we have started the SD-WAN journey with a partner called Versa Networks back 3 years ago. So the first kind of implementations to SD-WAN were done on the Nordic scale with Versa. And then it also expanded to multiple vendors, I would say, and multiple products. So the current product portfolio based on which partners or vendors we are using is also the Fortinet, is also HP Aruba and Cisco Meraki, and probably some more names that will be coming. But again, we are focusing on Global Connect value and what Global Connect SDX functionality is, and not just being a reseller of some vendor functionality. So that's why we believe our input is also that we have the technical experts understanding the customer needs and choosing the right design no matter of which vendor we use to realize these solutions. And we have a good delivery approach, and then also definitely the operation stuff with SLA and good customer contact and fixing the different issues. And then again, the portal for letting the customer to basically be aware of different delivery status, and then also the status of the network, the quality, possible threats, and things like that, which gives a nice feeling that you are in control of the network kind of size of it. So that was basically my experiences on my journey in Global Connect, and we are looking for new hiring or older hiring or kind of younger, no matter. So if you are somewhere in the path of looking for something else and think that SD-WAN or SDX or whatever is interesting activity, so I'll be joining the dinner, so then we can take a dialogue. Or if you have any other questions as well about the presentation or kind of the technical topics, also feel free to shoot. I have 2 my team members as a backup, so I'm quite secure that we will be able to answer the technical questions. But at the same time, it will be interesting to hear different experiences if you have been working with software-defined technologies, and how do you find that different challenges in different contexts and things like that. So that's me. I'm Loretta, and I'm still love SD-WAN or SDX now, right now. So thank you.
Do we have any questions? Questions, anybody? No. Right. Thank you very much, Loretta.
Thank you.
Just a second, so I take over the slides. Yes. So we are now over with the program part, and I hope you found it interesting and pleasant, and enjoying the extended mingling opportunities throughout the day. I realized today that I didn't get to introduce myself in the morning. By now, I guess everybody knows me, but there's also a Nonog team which helped make this event possible. So I would like just to name and present a bit the team. So in the Nonog team is Eirik, which is behind there. It's Lars and Ture, and myself, Marius Malaya, which we worked through everything with the program, the social, as good as it was, and everything preparing all the details and communicating with the sponsor and everybody. So I would like to thank the team as well for the help, and I hope you found the event to your expectations. If we get time, we will prepare a bit of a survey, which you will receive on email, but in a week or so, we'll see if we get time. But if not, just send any feedback you have, good or bad, about anything from how the room was to details in the presentations, and then we will try to get it and work. If you want more technical content, less technical content, and whatever feedback you might have, just reach out on email. Apart of that, I would like to thank the speakers who dared to come forward and talk and present and put themselves in a slightly vulnerable position. At the same time, it's an opportunity for most of you to present. And in the end, the restaurant. I would like to tell you that we can now wrap and head over to the restaurant. We are expected to be there at 5 o'clock. It's just across the train tracks, which you see in the middle. The address is Askekroken 11, but you just Google the name of the restaurant you have here, and then you can come there. So besides that, I would like to thank you, the audience in the room and remote, for attending. And send feedback and see you all at the next event. Thank you very much.